life. Can we live without water? No. So that is all. We have substitution. We will be frequently using that substitution part in this, and main topic will be partial fraction as well as by parts. Let us recall some of the formulae needed to this class. So we have studied standard integrals. In the fourth exercise we have studied 6 standard integral, and later on we have studied 3 more standard integral. Hope you remember that. Shall we recall that? Yes. 1 out of the 6 will be integration of 1 divided by x square minus a square dx. So out of the 6, the first one, so it is given by the formula 1 divided by 2a into log of modulus of x minus a divided by x plus a plus the constant c. In connection to this, there is one more, that is just interchange of a square and x square. So it is a square minus x square dx, which is with the answer 1 by 2a log of mod. Here it will be a plus x divided by a minus x plus c. Along with that, there are 4 more. The next 2, 1 divided by a square plus x square dx, and that is given by the formula 1 by a tan inverse of x by a plus c. And the fourth one, that is integral of square root of a square minus x square dx. And you know there is no coefficient to this, it will be sine inverse of x by a plus c. And there are 2 more, the last 2, it is almost same, that is integral of 1 divided by root of a square plus x square dx, which is given by the formula log of x plus root of a square plus x square plus the constant c. And there is the last one, integral of 1 divided by root of x square minus a square dx, and it is similar to it, much of difference is not there, log of x plus root of, instead of this term we have root x square minus a square plus the constant c. So these are the 6 important standard integrals. So there will be a number of questions based on this, and moreover next addition to this there are 3 more standard integral. Those 3 standard integral are integral of root of a square minus x square dx. Even in the very next chapter you come across a number of times the very same formula. It is given by x by 2 into the same integrand root of a square minus x square. As x square has the coefficient positive sign, it will be plus a square divided by 2. Based on the 6th standard integral we write the second part, that is sine inverse of x by a. So connection to this there are 2 more, that is root of a square plus x square dx. You can consider it like this. Here it is the first term, there is no much difference, coefficient will be x by 2. With the same integrand root of a square plus x square. As a square term is positive, here also the sign will be positive, a square divided by 2. Based on the 6th standard integral, you can write the second term, that is log of mod of x plus root of a square plus x square plus the constant c. And one more, that is the third one, that is integral of root of x square minus a square dx. So here it will be x by 2 into root of the same integrand, that is x square minus a square. Just observe, is it not a square negative term? So therefore the in between sign is negative, a square divided by 2. Connected to the 6th standard integral, it will be log of mod of x plus root of x square minus a square plus the constant c. So these are the basic formula which we have come across in the NCERT textbook. And moreover, we need one more part. That part is by partial fraction. That is based on this 6 standard plus 3 standard integral. There are few questions, and let us recollect how to handle partial fractions. See, we can consider it like this. If the integrand appear in the form of linear factors, that is x plus a into x plus b dx, if it is written as a product of different linear factors, then we will have to just consider the integrand 1 by x plus a into x plus b. You will have to split it, resolve into partial fraction, and what will be, how to rewrite it? Yeah, you will have to write it as a constant a divided by one of the linear factors, and next b divided by another linear factor. If there is one more term, there will be another term. So that is one of the type. And let us go for the next type. If the integrand has some, maybe here it is px plus q. If there are some factor which are repeated, see here I have considered like this. X plus a is a non-repeated factor, whereas x plus b is repeated twice. It may be repeated any number of times. What we have to do is fix a constant above the non-repeated factor. Let us consider it as a. And then as we have x plus b whole square, another term will be b divided by x plus b, as it is raised to 2. So one more term will be there, c divided by x plus b whole square. So this is in the case of when the factor is repeated. As well as there is one more, that is if it is of the form px plus q divided by ax square plus bx plus c into, let us consider the factor x plus d. So now you just observe, you can find a quadratic expression in the denominator, but if it is not possible to factorize, if it is possible to factorize, it belongs to the first or the second type. If it is not possible to factorize, the way we have to rewrite it is, below the quadratic expression ax square plus bx plus c, you have to fix a linear expression, that is capital Ax plus b. And then next, if there is one more factor, above that you have to fix another constant, that is all. So now either by easy methods you can find it, or else we will have to go for cross multiplication and obtain. When it is actually, when you solve the problems, let us discuss that. And this is all about partial fraction, and you have to be very careful. If it is a improper fraction, all that you have to do is divide it, ordinary long division method, and then the improper fraction you will have to resolve it. For example, if it is like this, x cube divided by x plus 2. See, the degree of the term x variable in the numerator is 3 and that of the denominator is 1. So it is an example for improper fraction. If they are of equal degree, of the numerator degree is more, then it is an example for improper fraction. Then you will have to just do long division method, and you will have to express it as a quotient plus remainder divided by divisor. So you will have to continue partial fraction using for the second part of this simplified answer. Then one more fact, that is integration by parts. Say integration of two functions, product of two functions are given to you. Integral of f of x into g of x dx. So if this is the case, then what you have to do is, you will have to apply integration by parts. And while you apply integration by parts, you can follow this I late, that I stands for inverse trigonometric functions. L for logarithmic, A for algebraic, T for trigonometric, and E is for exponential functions. And the order of preference is based on this I late. Then let us assume that f of x is the first one, g of x is the second function. When you integrate it by parts, the formula goes this way. First function into integral of the second function minus integral of the second function into f dash, that is derivative of the first function. So this is what integration by parts. So these are all the basic formula we come across, and then if when needed I'll give you extra points. Let us discuss the test paper. Hope you are ready. So mainly we have considered exercise 4 to exercise 7. Yeah. So here is the first question. Let us go to solve it. Just observe it. How do we handle it? See, here is the term numerator, there is x power 2. But what is degree of x in the denominator? X to the power of 6. Is direct substitution possible? If it is direct substitution, that is x raised to 6 is equal to t. What is derivative of x power 6? 6x to the power of 5. But is there x power 5 term? No. So let us think about the substitution that x to the power of 3 is equal to t. So what happens on differentiating? 3x square dx will be equal to dt. So let us do that here. So the integral will be integral of, see, we can find here x square dx. When 3 is shifted to the right side, it will be dt divided by 3. And we are with, in the denominator, root of. How do we rewrite x to the power of 6? X cube whole square. And our x cube is t, so it is t square plus we can write a cube whole square. Now is it one of the standard integral? Yeah. Let us keep that 1 by 3 outside. Compare it with the 6 standard integral. On comparing that, don't we get the answer as log of, here, modulus of t. That t plus root of t square plus a cube whole square. Now you will have to replace that t. What is our t? X cube. So let us identify the correct option. Is it here? Option C. 1 by 3 log of t will be x cube plus square root of x cube whole square will be x power 6 plus a power 6 plus c. Hope you understood the solution given to this problem. Okay. Next, moving on to the second question. See, you can find a quadratic expression inside the root sign. So you remember completing square. The quadratic expression is 5 minus 2x plus x square. So we have studied formula method or completing square. Let us follow that. So the first term, it is x square. We are writing it as a minus b whole square. So when you try to write, here it is the x term minus, because this linear term has negative, here it is minus half of the coefficient of x. So x has the coefficient 2, its half will be 1, that whole square. Now we will have to add this b square we have already added, subtract b square, that is 1 square, and the other term, that is plus 5. So that is simplified to x minus 1 whole square, 5 minus 1 it will be 4, which you can write it as 2 square. So let us use the formula. We can rewrite it, integral of root of, this can be written as x minus 1 whole square plus 2 square dx. Is it not 1 out of the 3 standard integral? Yes, using that. Which is the suitable answer? The answer is x minus 1 divided by 2. Which are the options give x minus 1 divided by 2. And inside we get the same integrand, multiply 2. and this is actually obtained from 5 minus 2x plus x square. Where do you find 5 minus 2x plus x square? Either in option B or in option C. First two terms are okay. Then next term is plus a square divided by 2. A square value will be 2 square, 4 by 2 it is 2. Then log of, here we have x minus 1. Is it not dropped? Because it was x plus 1. So the suitable option will be this, plus root of the same integrand plus c. So we got the answer, it is option C. Next, here is the third question. So here is integral of sin x divided by root of 4 minus cos square x dx. Does it look like one of the 6 standard integral directly? No. But two variety functions are there. One function is sin x, another function is cos x. So let us think about the substitution. What will you choose? Which function will you choose for substitution? Cos x. Exactly correct. Cos x equal to t. What is the derivative of cos x? Yeah, minus sin x dx is equal to dt. Let us write it in terms of t, variable t. Sin x dx, from the second equation it will be minus dt divided by root of 4 can be written as 2 square minus this will be t square. So this is of the form 1 divided by root of a square minus x square. So what is the standard formula? This minus sign will be the minus sign of this. Using the formula it will be sin inverse of t divided by a plus the constant c. What is actually t? It is cos x. See whether you find the answer somewhere here. The last one. It is option D. Minus sin inverse of cos x divided by 2 plus c. So that is the solution to the third question. So here is, you can't see 2 terms in the denominator, but there are extra. Can you find more than that 3 terms? Whenever the function appear in the form of denominator 1 divided by a cos square x plus b sin square x plus c, the easy method to transform into the 6th standard integral is divide the numerator as well as the denominator by cos square x. When you divide numerator and denominator by cos square x, 1 by cos square x can be written as secant square x. Keep in mind the denominator is of the form of a cos square plus b sin square plus c. In such a situation, you divide numerator and denominator by cos square. And the first term 1 by cos square, is it not secant square? Yes. The next term 3. And what is sin square x divided by cos square x? It is tan square x. And the next term 8 into cos square by cos square, simply 8. So much dx. Is there some connection between these two? Yes. How do you rewrite it? Numerator secant square x, let it be the same. And this secant square x can be written as 1 plus tan square. And that 1 I add it to 8. So it become 9 and rewrite it as 3 square. And plus tan square added to 3 tan square. So together how much tan square it will be? 4 tan square x. And how do I rewrite 4 tan square x? 2 tan x whole square. Now it is very clear the substitution. What should be the substitution? 2 tan x equal to t. When you do the substitution, 2 tan x is equal to t. Here 2 into secant square x dx will be equal to dt. Either you can identify the answer directly, or else let us do this and substitute it. So this can be written as dt divided by 2 divided by t square plus 3 square, which is a suitable answer. What about that? It is 1 by 2 into, what is the formula for 1 by t square plus a square? It is 1 divided by a into tan inverse of t divided by a. A value is 3. So let us search the suitable answer, that with a coefficient 1 by 6. either option A or option B. Then tan inverse of t, which is t in this, 2 tan x divided by A will be 3. So A will be the right option. That is all. Hope you understood what to be done when the denominator appears in the form of a cos square plus b sin square plus c. So this is another question, almost same as earlier discussed, but the formula used will be a bit different. So here also cos x is the substitution. When you substitute cos x equal to t, you get minus sin x dx will be equal to dt. So when written in form of t, sin x dx will be minus dt, and the denominator 3 can be written as root 3 square. And how do you write 4 cos square x? You can better substitute 2 cos x equal to t, or else we already did it, let it be there. Okay, we are avoiding that, not to cos x equal to t. How to rewrite? It can be written as 2t whole square. Okay, when it is of this form, this is discussed formula itself. What is the formula? 1 by a value is root 3 into tan inverse of x is replaced by 2t divided by a is root 3. What is the extra part to this? See, this variable t has a coefficient 2. So what is to be done? We have to divide the integral by 2. 1 by 2 root 3. Is there any option with 1 by 2 root 3? And moreover, it had a negative sign, so it is minus 1 by 2 root 3 tan inverse of 2 cos x divided by root 3 plus c. Because of this derivative, we got minus dt. That minus sign is carried here, that is found in the option A. Yeah. So we have considered one problem related to this. I am sure you will say it. What you might be with the answer. What is the change we have to do it? Divide by numerator and denominator by cos square x. So you just find it. How does it change when it is divided by cos square x? Numerator will be secant square x dx. What is the denominator? One of the term. It is a square tan square x plus b square into 1. Cos square by cos square will be 1. Then use the 6th standard integral here, a tan x equal to t. When it is a tan x equal to t, you get the answer using directly we can write 1 divided by b. What is the reason for 1 by b? Out of the 6th standard integral, 1 by, instead of a we can find b. So 1 by b tan inverse of, what is the x term in it? That is a tan x. So that is a tan x divided by, actually a is replaced by b. Because of this coefficient tan x as a, what should we further divide the entire integral by? A plus the constant c. So the suitable answer is found in option A. Hope you are able to follow the classes. Here is the next one, that is sin x divided by sin 3x. What shall we do? Here, see, sin 3x, we know the formula. What is the formula for sin 3x? 3 sin x minus 4 sin cube x. But there was sin x in the numerator. Let us bring that to the denominator. Divide the numerator and denominator by sin x. Sin x by sin x is 1. When this term is divided by sin x, this is cancelled. Second term divided by sin x, it becomes square. So is it not the standard integral dx divided by 3 can be written as root 3 square minus 4 sin square can be written as 2 sin x whole square. So we can easily identify the answer. So this is of the form 1 divided by a square minus x square. So you know it is first 2, 1 out of the first 2. 1 by 2 into a. What is a in it? Root 3 1 by 2a log of a plus x. What is a here? Root 3 plus x term is 2 sin x divided by a minus x, 2 sin x. But there is a coefficient to sin x. So we will have to divide by that coefficient, that is 1 by 2. So the denominator, that is coefficient 1, will be 1 by 4 root 3. Is there a option 1 divided by 4 root 3? No, that is missed. Just a minute. So this is transformed to just a minute. Okay, let us try it once again. If we again see the mistake, we won't be able to handle it. So dx divided by, there was 3 is written as root 3 square minus 2 sin x, 2 sin x whole square dx. Yeah, what is missed here? Substitution. The mistake happened is, if you substitute 2 sin x equal to t, what should be there with dx? Derivative of sin x, cos x should have been there with dx. But that is missing, so this is a wrong way. So we will have to again go back to the old category. Just we observe the options. Once if we observe the option, which is the trigonometric function found here, tan, is it not? So what is that we have to do? So we have to divide the numerator as well as denominator by cos square. So let us divide numerator and denominator by cos square. When you divide numerator and denominator by cos square, it is integral of, the numerator, it is 1 by cos square, which will be secant square. And the term there was 3. 3 divided by cos square simplifies to 3 secant square x. And the in between term was minus. There you had 2, was it not? It was 4 sin square x. And what do that become? 4 sin square x. 4 sin square x changes to 4 sin square by cos square, which will be equal to tan square x. So much dx. Now this will be secant square x dx divided by this 3 secant square x. How shall we write it? 3 into 1 plus tan square x. And one more term is minus 4 tan square x. So here the numerator will be secant square x dx. And the denominator 3 can be written as root 3 square, and we have 3 tan square x minus 4 tan square x, which is simplified to tan square x. Now let us substitute tan x equal to t. When you do the substitution tan x equal to t, numerator will be dt divided by root 3 square minus t square. And from the standard integral we can write it like this: 1 divided by 2 into root 3, that is 2a, 1 by 2a into log of, what is the suitable formula? A plus t, and the t will be tan x divided by a minus tan x. Let us see whether this option is found in the out of the 4. We got it as 1 by 2 root 3 log of, there are 2 options here, 1 by 2 root 3, and we have root 3, log of root 3 plus tan x divided by root 3 minus tan x. So option A is the suitable option. Okay, so these are the questions which I have considered for 6 standard integral as well as the 3 standard integral. Now let us move on to the next topic, that is integration by partial fraction. So by the method of partial fraction, see, you can find 2 factors in the denominator. Are the 2 factors distinct factors? Yes. So we know when they are non-repeated factor, it is 1 by x plus 1 into x plus 2, we will have to write it as a divided by x plus 1 plus b divided by x plus 2. Let us find out this a value and b value by using shortcut formula. To get a value, you should think a value of x so that this factor becomes 0. So x equal to minus 1, make it 0. So avoid this factor, let us avoid this. In the remaining, substitute x equal to minus 1. So we get a value is equal to 1 divided by 2 minus 1, it is 1. So we are with a value 1. And to get b value, just try for a value where this factor becomes 0. X equal to minus 2, make it 0. Now we will have to avoid this factor x plus 2. In the remaining, substitute x is equal to minus 2. You get b is equal to 1 divided by minus 2 plus 1, which is minus 1. So this is transformed to 1 divided by x plus 1 minus 1 divided by x plus 2. On integrating, let us find the answer, that is log of x plus 1 minus log of x plus 2, which is the property used, log m minus log n. So log m by n, so we get it as log of x plus 1 divided by x plus 2 plus c. That is option C. So coming to the ninth one. So this variety question is usually asked in the CET level. So we have the right side already integrated, it is given to us. But what are unknown to us? The coefficients are unknown to us. We have to find a value as well as b value. So let us think how to handle the integrand given here, 1 by x plus 2 into x square plus 1. So here we are able to split it as a divided by x plus 2 because it is a linear factor. But this is a quadratic factor. Is it possible to factorize? No. As it is not possible to factorize, we write its numerator as bx plus c divided by x square plus 1. Let us go for the shortcut method and find out the value of a. We need to give the value of x equal to minus 2. So when you avoid this and give x equal to minus 2, so minus 2 square, it will be 4 plus 1, 5. So a value will be 1 divided by 5. And after integration, that will be 1 divided by 5 into 1 by x plus 2. On integrating, what is integrated answer of this? Log of mod of x plus 2. So there is a term log of mod of x plus 2, its coefficient is already given to us. So we need to handle the rest of the term, that is this term. We need to find b term as well as c value. In order to find b value and c value, let us simplify it. Multiply the entire equation by LHS denominator. When I multiply the left side denominator, LHS become 1 and the RHS, here we know a value is 1 by 5. Multiply with x square plus 1 because x plus 2 is cancelled on multiplying by this term. Here when you multiply by that denominator, we get bx plus c multiplied to x plus 2. Now we need the value of two things, that is b as well as c. When you compare the coefficient of x square, in the LHS, x square coefficient is 0. Here x square coefficient is 1 by 5 and this is the x square coefficient, that is plus b. So what is the value of b? b will be equal to minus 1 by 5. And one more term c is needed. Just substitute x equal to 0. When you substitute x equal to 0, LHS is 1. Here the term will be 1 by 5. Here when it is 0, it is 2c. So we need the value of c. C value will be 1 minus 1 by 5, which simplifies to 4 by 5 equal to 2c. After cancellation, c value is equal to 2 divided by 5. Now we will have to just think about this term integration. We got b is 1 by 5, x plus c is 2 divided by 5 whole divided by x square plus 1. How can you split it? When you split it, you will be able to write it as x into 1 by 5 into x square plus 1. Similarly, another term is 2 divided by 5 into 1 divided by x square plus 1. So think about this term integration. What is the integral of this term? 2 by 5 into tan inverse of x. And is there a term with tan inverse of x? Yeah, here you can find tan inverse of x. Its coefficient is plus b. So plus b will be 2 by 5. Is the options with b as 2 by 5? Either it is option C or it is option A. Next we will have to think about the other term integration. How to integrate it? This is by the method of substitution. When you do the substitution, here x square plus 1 equal to t. So 2x dx will be equal to dt. So we are substituting, that is x dx will be dt divided by 2. Already there will be 5 and this will be t. So you know it is 1 divided by 10 into log of t. T is actually x square plus 1. So let us see log term what the coefficient is. We got the coefficient as plus 1 by 10. Here there is plus a. So a will be plus 1 by 10. That is option D. D will be the right answer to that. So there is one more question of the similar kind. Hope you will do that. Yeah. Here is the next one. We have studied this as a ready-made formula. What is the ready-made formula we have studied in the class? The formula that we have studied is integral of 1 divided by x into x to the power of n plus 1 dx. The formula, you know it. What is the answer? 1 divided by this term n into log of, you have studied that as x power n plus 1 divided by x power n plus c. Let us use the same term, that is n is replaced by 5. So here the suitable answer will be 1 divided by 5. 1 divided by 5 log of x power 5 plus 1 divided by x power 5 plus c. Using the very same formula, it is option A. So hope you will remember that formula. So then it will be easy. Otherwise we will have to go for partial fractions. So even this is a type of partial fraction itself, but the substitution we need it. What is the substitution to be made? Substitution to be made is sin theta is equal to t. Then what do we get? Cos theta, d theta will be equal to dt. So this is easily simplified to integral of dt divided by 2 plus t into 3 plus 4t. So let us think about the integrand. The integrand is 1 divided by 2 plus t into 3 plus 4t. So what value of t make it 0? T equal to minus 2. So when t equal to minus 2, let us think what the value of the remaining function is. We are avoiding this factor and it will be 1 divided by, when t value is minus 2, so it will be 3 plus minus 8. So that simplifies to minus 5. So it will be minus 1 divided by 5 into 2 plus t. And we need to fix the numerator of 3 plus 4t. Then let us think what value of t will make this factor 0. If t is equal to minus 3 by 4, then this factor is going to be 0. Let us substitute t equal to minus 3 by 4 in this part. When you substitute t equal to minus 1 by 4, if I consider it as b, then b will be equal to 1 divided by 2 minus 3 by 4. On simplifying, it will be 8 minus 3, 5, and 4 in the numerator. So it will be 4 divided by 5. So this will be plus 4 divided by 5 into so much. Now let us integrate those terms. What is the integral of the first function? Minus 1 by 5 is the constant. What is the integral of 2 plus t? Log of 2 plus t. And we have log of 2 plus t with coefficient minus 1 by 5. That is minus 1 by 5 log of 2 plus t. And let us integrate the second term. 4 by 5 will be the coefficient. What is the integral of 1 by 3 plus 4t? Log of 3 plus 4t. Do you find a coefficient for t? So divide by 4. When you divide by 4, these two cancel. We can keep 1 by 5 outside. This log m minus log n. Do we find that answer? Where do we find 1 by 5 outside? It is here. Log of 3 plus 4t. Because of this minus sign, this comes to the denominator 2 plus t. That is option C. So let us come to the 12th one. So even here it is of partial fraction. You might have noticed degree of x in the numerator as well as degree of x in the denominator. So it is of 3 and this is of 1. So we need to do long division. When you go for long division, here you get, let us divide it here, x cube divided by x plus 1. On dividing, what about the first term of the quotient? X into x square makes x cube plus 1 into x square, that will be x square. After subtracting, here it is cancelled, this will be minus x square. Now we need to decide the second term of the quotient, that is x into minus x gives minus x square. So 1 into minus x, that is minus x. So even this is cancelled, so it will be x. So here is x. Now it is of equal degree, so x into 1 makes x, and so 1 into 1, that will be plus 1. After cancellation, here on subtracting 0 minus 1, the remainder will be minus 1. So we will rewrite it. The quotient is x square minus x plus 1. So let us rewrite here. So we can write it as x square minus x plus 1 was the quotient plus remainder is minus 1 divided by divisor is x plus 1. So much dx. And let us search for each term integration. X square integration is x cube divided by 3. It should have been positive. Either option A or option D. X cube by 3 is positive. And minus x integration is minus x square by 2. So A is dropped, D is correct. Is it the rest of the term correct? 1, it is x. Minus its integration is log of 1 plus x. So it is option D. So coming to the 13th question. Here we can find two terms in x. Both the terms are also quadratic degree. So if you actually go for the method, is it not a type where the quadratic expression is not possible to factorize? In such a case, easiest way is replace x square by y. When you replace it by y, you can write the integrand 1 divided by x square plus 4 into x square plus 9 as 1 divided by y plus 4 into y plus 9. So we are able to resolve into partial fraction. On resolving into partial fraction, let us identify the numerators of y plus 4 and y plus 9. In order to find out the numerator of y plus 4, we should substitute y is equal to minus 4. Avoid this factor, substitute y equal to minus 4, 9 minus 4, answer is 5. So a value will be, or its constant will be 1 divided by 5. So it is 1 by 5, and now we need to make it 0. Y equal to 9, make it 0. Now we are avoiding this factor. In the rest of the term you substitute y is equal to minus 9. So it simplifies to 1 divided by minus 5. So it is 1 divided by minus 5 into y plus 9. Now we did not substitute, we just replaced. As we have replaced, what shall we do? Here we will have to go back to the original variable. So the given integral will be 1 divided by 5 into y can be written as x square plus 4 dx. Another integral will be 1 by 5 into integral of 1 divided by x square plus 9 dx. Both the terms it is ready with the answer. Out of the 6 standard integral, 1 by 5 is the constant, and what is the integral of this term? It is 1 divided by a, because a will be 2, that is 4 can be written as 2 square. 1 by a, tan inverse of x divided by 2. Do we have a option 1 divided by 5 into 1 by 2 tan inverse of x by 2? Yeah, it is here. Then another term, 1 by 5 is the coefficient outside. This will be 1 by 3 tan inverse of x by 3. That is found in option B. So B is the right answer. Hope you got, as both the terms were x square, we could replace x square by y. So simplification, it is possible a bit easily. That's all. So we have discussed a question similar to it. Now I leave it to you as homework. Just try it. There was slightly change in it. The numerator, again it was a linear expression, and here there was change in the denominator signs. You just attempt it as a homework. Later on you do it. It is one of the past year CET questions, that is in 2019 the same question appeared. So now here we have dx divided by x square minus 3x plus 2. So here is the denominator. Is it possible to factorize a question to you? How is it possible? What are the factors of that? The factors of that will be x minus 1 into x minus 2. So on opening the bracket we get the same factor. Follow the direct method, integration by partial fraction. Fix the numerator for x minus 1. What will be the numerator for x minus 1? Avoid this. Substitute x equal to 1. When you substitute x equal to 1, 1 by minus 1. So the answer will be minus 1. Fix the numerator for x minus 2. What will be the substitution to be made? X equal to 2. When you substitute x equal to 2 in this factor, you get 1. So it will be plus 1. Now let us go for the integration. This is minus log of x minus 1. There it will be log of x minus 2. Is there an answer accordingly? Log x minus 2 divided by x minus 1. That is option B. So that is the solution to question number 15. Hope this type is also over. You may carry on that as homework. Here you need to find out 3 unknown values A, B, C. You can find it. It is simple and easy. Just try to complete it by your own. And the next one we have integration by parts. So when it is integration by parts, we will have to think about the variety of functions appeared here. Which are the 2 category functions in this? Algebraic function as well as trigonometric function. According to the order of preference, which will be given the first preference? Algebraic function. So this will be the first and this will be the second. So let us go for the easy method. Easy method is like this. If there is integral of uv dx, where u is a function of x, v is also function of x. we write the first function as it is. We integrate the second function. Let me denote integral of v as v dash, first integral. Then as it is positive, next is negative. Differentiate the first function u1 and then integrate this function v dash. Once again integrated, I will denote it as v2. And then next positive, negative, sign should be positive. So here once again differentiate u1, derivative of u1 we will denote it as u2. Now we will have to integrate v2. When integrating v2 you get v3. Hope you got the sequence: positive, negative, positive, negative, continued. Alternatively it continues, and the first function is to be differentiated, second function is to be successively integrated. Now here we are with this, u will be x cube and this will be v. So let us go for that. We are writing the first function as it is, x cube. Let us integrate sine 3x. What about integral of sine 3x? Minus cos 3x divided by 3. As the first term is positive, next is negative. Differentiate x cube. What is derivative of x cube? 3x square. Now you need to integrate this function entirely. Minus 1 by 3 is the coefficient. What is integral of cos 3x? It will be sin 3x divided by 3. Next, positive, negative, next term should be positive. Now differentiate 3x square. What is derivative of 3x square? It is 6x. That is multiplied to integral of this function. Here already there is negative sign. Now integration of sine function has another negative. So it will be cos 3x. Already there is a coefficient 3 into 3, 9. Once again divided by 3, it will be 27. Now this was positive, so it will be negative. What is derivative of 6x? It will be 6. Integrate this function. Integrating the function, it will be sin 3x divided by 27 into 3, it is 81. Now what would be the next term? Derivative of 6 will be 0. So no more term further. So it is stopped. So now you will have to see the first term, minus x cube by 3 cos 3x. Is there anywhere minus x cube by 3 cos 3x? Is it D option dropped? Now we have minus x cube cos 3x by 3 in all the 3. And what about the next term? 1, 3 is cancelled with this 3. Negative into negative, it will be positive. X square by 3 sin 3x. Either option A or option C. Is it B dropped? Okay. Next we have one more. We can simplify it. 3 2 times, 3 9 times. It is positive 2 by 9 x into cos 3x. 2x by 9 cos 3x, but this is dropped, it has a negative sign. Then the last term after simplification you get this, it is option A. So even this was a question from the past year CET 2019. Then here, if we handle it directly, it's lengthier and it is very easy. Within 1 minute we can handle it with a ready-made formula. The ready-made formula is e to the power of ax into sin bx dx. Here a is coefficient of x, b is coefficient of x in the sin function. If the function appear in this form, the answer is e power ax divided by a square plus b square into the coefficient of x in exponential a. We will write the same function sin bx. That sin bx, as it is sine function, in between sign is negative. Here is a, next coefficient will be b. Here we used sine function, so it will be cos of the same angle bx plus c. Now let us try what is our a and what is our b. A value is minus 2, b value is 3. So we will go for this e power minus 2x, this option as well as b. Then a square plus b square, 2 square plus 3 square, it will be 9 plus 4, 13. Let us see whether if, this was dropped in the beginning itself, either A or D. Now we will have to think about this part. A will be minus 2 sine Bx will be 3x, minus 2 sine 3x minus B is 3 cos 3x. Is it not both the term negative? Take the negative sign outside and we have 3 cos 3x, 2 sin 3x, both are positive and negative sign taken outside. This is the answer. So there is one more formula along with this, e power ax cos bx dx. If it was cos function, this coefficient remains same, e power ax divided by a square plus b square. Now the first term will be a into cos bx, that is cos bx here. Because of this cos function, the sign will be positive, but here it was negative, here it is negative, and negative for sine function, positive for cos function, and now a is used here, b, the other trigonometry sin bx. So that is the formula for e power ax into cos bx. So that easily you can get it. So while doing the regular classes, it was discussed in the class. Hope you might have noticed that and you are using it. Then here it is product of 3 functions. How to apply integration by parts? We need only 2 functions, is it not? So let us think about some transformation. We can rewrite it like this, x as it is, sin x same. I am going to split sin cube x. Let me write it as secant x into secant square x dx. What about sin x into secant x? Yeah, it will be sin by cos, which will be tan. So we are able to do the substitution, tan x equal to t. Then secant square x dx will be equal to dt. So we got it, x as it is. What about x from this? Tan x equal to t. What do this imply? X is equal to tan inverse of t. So we are writing x as tan inverse of t, and next we come across, this is tan x should be substituted as t, secant square x dx is written as dt. Then we have inverse trigonometry, algebraic, according to I-late, which will be the first function, inverse trigonometry. So the first function, tan inverse of t, integral of t will be t square divided by 2, minus integral of t is t square by 2, and derivative of tan inverse function is 1 by 1 plus t square dt. So we completed integration in the first part. We will have to integrate it. 1 by 2 can be put outside. Then how to handle it? We have discussed it in the previous sessions. We add 1, subtract 1. When we add 1, it will be t square plus 1 divided by 1 plus t square minus 1 divided by 1 plus t square dt. So we know this is cancelled and it is equal to 1. What is integral of 1 dt? It is t. So this is simplified to tan inverse of t into t square divided by 2 minus 1 by 2 is the coefficient, integral of 1 dt is t, and one more term minus integral of 1 by 1 plus t square will be tan inverse of t plus the constant c. Let us observe what is tan inverse of t. Tan inverse of t is x. T square will be tan square. So we will have to write it. This will be x and this will be tan square x divided by 2 minus 1 by 2 into t. What is t? T will be tan x, and this negative into this negative, it will be positive 1 by 2. Tan inverse of t will be x plus the constant c. Is there a option accordingly? Yeah. 1 by 2 is common to all the terms. We have 1 by 2 in all the 4 options. We have 1 by 2. And when you keep 1 by 2, here is x into tan square, x into 1. Let us keep x outside. When you keep x outside, yeah, here 1 by 2 is generally kept outside. When x is here, tan square x plus 1 Is it not secant square x? X. This half is put outside, minus tan x plus the constant c. And you just search for that option, that is half into x secant square x minus tan x plus c, that is found in option B. So B is the right option for that. Okay. So we are with the 20th question. So already it is integrated. We need to find out the unknown values a, that is all to be found. So let us try to integrate it. So when you go for that, let us find how to integrate it. Just treat it as first function and the second function is 1. So first function is log of x square plus x into integral of 1, that is x, minus integral of 1 will be x. What is derivative of log x square plus 1? It is 1 divided by x square plus x into derivative of x square plus x is 2x plus 1 dx. We can keep x square outside and it will be cancelled. So the second function for integration will be 2x plus 1 divided by, after cancelling x, what is remained here? X plus 1. The first term remains same, log of x square plus x into x. That will be the same. Now we need to integrate this function. Let us go for partial fractions because they are of same degree. As they are of same degree, we need to divide 2x plus 1 divided by x plus 1. 2x plus 1 by x plus 1. When you divide it, x into 2 makes 2x. 1 into 2, it will be 2. After subtraction, here the remainder will be minus 1. So we are able to rewrite. I'll rewrite the second part here. There will be a minus sign. Integral of, the quotient will be 2. Remainder is minus 1 divided by x plus 1. So this is the second term for integration. Minus the sign will be outside. Integral of 2 dx, it is 2x minus integral of this function will be log of x plus 1 plus the constant c. Let us search for the suitable option. What makes a? I think the first term was directly given to you. That is here. Now we need to find a. What is a? This term entirely, which is a suitable option there. That is log of x plus 1 minus 2x plus c. That is option D. Hope you understood the solution given to the first 20 questions. Yeah. Yes or no? So again we need to go for integration by parts itself. Here we have the function sine of log x multiplied to 1. So the first function will be sine of log x, second function is 1. Let us use integration by parts. First function sine of log x, integral of 1 will be x minus integral of 1 is x, derivative of sine function is cos into derivative of x is 1 by x dx. Here it is cancelled. The first term will be same, x sine of log x minus integration of cos log x. What is the integral of cos function? Is it there in the ready-made answer? No. Once again we will have to integrate it by parts. When you integrate it by parts, first function will be cos of log x into integration of 1 will be x minus integral of 1 is x, derivative of cos function will be minus sine of log x divided by x dx. This x is cancelled with this x. Now we have integral of sine log x dx. Is it not the question also integral of sine log x dx? Let us name it as I. So that I, integral I will be so we hence get I is equal to x into sine of log x. Here the next term minus x into cos of log x These two multiplied, it will be negative. Integral of sine log x dx will be I. Shift it to the other side, so it will be 2I. From these two terms we can keep x outside. It will be sine of log x minus cos of log x. We will add the constant as C1. So there will be answer after dividing by 2, we get the suitable answer. The suitable answer will be x divided by 2 sine log x minus cos log x. Is there that option, x by 2 sine log x minus cos log x? That B will be the right option. So coming to the next one, once again you can do integration by parts. Using integration by parts you can complete it. That is, we choose the first function as x cube and the second function as log x whole square. Hope you can complete it by your own, choosing the formula integration by parts. Next, let us come to the 23rd question. Here is tan inverse of root x. So even here there is only one function. What shall we do? Yeah, UV rule is to be applied, or we are rewriting it as into 1 dx. So let us go for integration by parts. That will be tan inverse of root x into 1, that will be x, minus integral of 1, it is x, and tan inverse of root x derivative will be 1 by 1 plus root x square, it is x, into derivative of 1 by, that is derivative of root x, that is 1 by 2 root x dx. So our target is completing this integration. How shall we complete the second part? You will have to think about that. So here x tan inverse of x will be as it is. Now think, how can we integrate this function? Is it possible root x equal to t? When you do the substitution root x equal to t, what is the derivative? 1 by 2 root x dx will be equal to dt. Now is that possible? 1 by 2 root x dx, that is equal to dt. This much is substituted as dt. How shall we write x? X will be t square, because squaring this. And here we have 1 plus x is again t square. We already came across the same integration today. It is x into tan inverse of x minus, how to handle it? Add 1 to it, subtract 1 from this. So we got the answer dt. So this is cancelled. Its integration will be 1 dt. Integration is t. Negative and negative multiplied, it will be positive. This will be tan inverse of t plus the constant c. So we have x tan inverse of x, and we have one more term tan inverse of root x and minus root x. We will have to choose the right option from the options. Let us go for that. Here there is coefficient for here I missed writing. This was actually root x. Here also it is root x. Even here it is root x. So tan inverse of root x has the coefficient that is 1 plus x. Is it here 1 plus x tan inverse of root x? And one more term is minus t. T is root x. So minus root x plus the constant c. So the mistake happened here is this should be root x. Here also it is root x, and here it is root x. So accordingly it will be option A option. Then coming to question 24. This is the last variety question. That is, we have studied one formula, integral of e power x into f of x plus f dash of x dx. What is the answer? Do you remember? It is e to the power of x into f of x plus the constant c. All that we have to do is only so much. We just find out which out of this is the function and which the derivative is. It never looks like sum of two terms, is it not? So we just have to do basic simplification, that's all. The numerator is 1 minus x whole square. What is the expansion of 1 minus x whole square? 1 plus x square minus 2x. And the denominator is 1 plus x square whole square. we will write as it is 1 plus x square whole square dx. Now we are able to split it. So this will be the first and this will be the second. So we have e power x 1 plus x square divided by 1 plus x square whole square. Is it not 1 by 1 plus x square? Then minus, here it is 2x divided by 1 plus x square whole square dx. So out of this is the function. Using chain rule, when you differentiate, the second term will be the derivative. So accordingly the answer will be e power x into 1 by 1 plus x square. That is option A. So we have few more questions remaining. Let us complete it at the earliest. Question number 25. It's so simple and easy. It is direct. It is e to the power of x. Which out of this is the function and which will be the derivative? Yeah, tan x is the function. And what is derivative of tan x? Secant square. Is secant square seen here? Yeah, we can write 1 plus tan square x will be equal to secant square x. So we got the answer e power x into f of x. That will be option A. So finally we have 5 more questions, that is 26th one. Is it not somewhat similar to the one which we did? Yeah, decide what will be the function in it, minus cot x. And what about its derivative? Cot x derivative is minus cosecant square x. So what will be minus cot x derivative? Cosecant square. 1 plus cot square is equal to cosecant square x. So we got the answer e power x into minus cot x. Is that found here? Yes, it is in option C. So the next one, it is 27th question. So is it possible to split into 2? That is what you have to think. How can we split this into 2? This e power x will be there as it is. See, we have x cube plus x. Let us consider x cube plus x. I am going to keep x outside. So what happens? It will be x square plus 1. That is divided by x square plus 1 to the power of 3 by 2. Then another function involved here is plus 1 divided by, is it not this term divided by the denominator we considered here? Another is 1 divided by x square plus 1 to the power of 3 by 2 dx. Now, is any simplification possible here? X square plus 1 power 1, x square plus 1 power 3 by 2. So we can write it as e to the power of x into x, let it be there. Now x square plus 1, 3 by 2 minus 1, is it not x square plus 1 power half? And now we have the other function 1 divided by x square plus 1 power 3 by 2 dx. So this will be the function and this will be its derivative. Just apply quotient rule and differentiate it, you get this as the derivative. So the suitable option out of this will be C option, e power x, x divided by whole power half can be written as root of x square plus 1. So let us move to the next one, 28th question. 28th is so easy as well as simple question it is. So that simple question, let us handle it. Only thing is how you break it, how you split it. Let us keep e power x as it is. How can I rewrite x minus 1 divided by x plus 1 whole cube? Just observe the denominator. What is the factor in the denominator? X plus 1. So let us make certain adjustment in the numerator. What adjustment is to be done? Add 1, subtract 1. Did you get it? See, the denominator factor was x plus 1. So we added 1 to it, simultaneously subtracted 1. So these two together, these two together. So much dx. So we can write it as e to the power of x. The first term x plus 1 divided by x plus 1 cube, 1 by x plus 1 square. Then minus 1, it is minus 2 divided by x plus 1 cube. So much dx. Obviously you know which out of this will be the function which is its derivative. 1 by x plus 1 square will be f of x. This will be f dash of x. So now you need to find out a value and b value. So we get the answer as e power x into 1 divided by x plus 1 whole square plus k. Now who is our a? A is coefficient of e power x, it is 1. And who is our b? B is power b, that is 2. Now we are asked b to the power of a, 2 to the power of 1, that is 2. That is all. And next 2 more questions are left. That is the 29th question. Yeah, we have our inverse trigonometry cos inverse. And inside this 2x square minus 1. What comes to your mind? Whenever we come across inverse trigonometry, one thinking, is it substitution possible? If at all substitution, what x make it cos function? Cos theta. So let us do the substitution. X is equal to cos theta. This is cos inverse of 2 cos square theta minus 1. Then what will be dx? Minus sin theta d theta. Hope you got it. X we are writing it as cos theta. So when you substitute, dx will be equal to minus sin theta d theta. And now here cos inverse of 2 cos square theta minus 1. What is that actually? Cos 2 theta. Cos inverse of cos 2 theta will be 2 theta into sin theta d theta. This is algebraic, this is trigonometric. Use the integration by parts formula and then integrate it. When you integrate by parts, here minus 2 I will keep outside. First function, integral of sin theta will be minus cos theta minus integral of sin theta will be minus cos theta into derivative of theta is 1 d theta. So that here it is minus 2, again multiplied it become plus 2 theta cos theta. And next term will be minus 2 into integral of cos theta will be sin theta plus c. Let us substitute it back in terms of x. So the first term is 2 into theta. What is theta? Cos inverse of x. And next term is cos theta. Cos theta will be x. And minus again 2 into sin theta. How to write sin theta in terms of cos function? It can be written as root of 1 minus cos square theta. So sin theta can be written as root of 1 minus cos square theta, that is root of 1 minus x square. So I am replacing that as root of 1 minus x square. Let us go for the options whether we have that as any one of the option. See whether it is there. Plus c. So do we find it? 2 can be taken outside. So there is in between sign negative. Is there a sign negative in between? Is it option C? 2 into x cos inverse of x minus sin inverse of x plus c. That is option C. Option A. What is a mistake here? Yeah, this is wrong, is it not? Not sin inverse of x, it is root of. Yeah, correct, you are correct. So it is 2 into, there we have x cos inverse of x cos inverse of x, 2 taken outside, root of 1 minus x square. That is option A. And then next we have the last question. So some technical issues here, I can't see the last question on the board. So the question is actually it is here, that is integral of e to the power of tan inverse of x multiplied to 1 plus x square divided by 1 plus x square dx. So here once again we are coming across with just a minute. So all these are of same category, but instead of x there is tan inverse of x. See, here we can find the variable of integration is x. So whatever about in here with e function, that will be the substitution. So we have to realize tan inverse of x is equal to t. From this we can make out that x is equal to tan of t. Then obtain dx. What will be dx? Dx will be secant square x dt. So we are coming back here. It will be differentiate with respect to x. Here it will be 1. Tan t derivative will be secant square t dt by dx, which will be written here. So that here we get it as integral of e to the power of tan inverse of x is t into 1 plus x is actually tan t plus x square will be tan square of t divided by 1 plus x square, that is 1 plus x square will be tan square t dx is secant square t dt. 1 plus tan square is actually secant square, gets cancelled with this secant square. And this problem we have handled it once today. So accordingly, what is e power t into the function, which is the function tan t. And its derivative is here. 1 plus tan square will be secant square t plus c. Let us come back to x. E power t will be tan inverse of x into tan of t will be x plus the constant c. You may find it in option A, that is x into e power tan inverse of x plus the constant c. So here ends the session with 30 questions. Hope we will meet soon in the classes. Thank you.
Hello. There was a technical error. Now please download a new question paper which is uploaded in the Ambika app. Okay, so last worksheet what I have provided, considered as a homework. Now in that paper, the first question, select the rate law that corresponds to the data shown for the following reaction, A plus B giving C. So these are the different trials which performed for this particular reaction. Now how to select proper rate law for this? By the way, you have learned what is the rate law. It is nothing but the rate of the reaction written in terms of the concentration of the reactant, right? So general formula to calculate rate is, this is it, am I right? R is equal to rate constant. So rate is equal to rate constant into concentration of A to the power some x and that of the B to the power y. So our intention is to find out what is that x value and what is that y value, right? So let us consider two trials in which concentration of any one of the reactant is constant. That is how the method is, or shortcut method is to solve this. So I'll go with the experiment number 1 where concentration of A is 0.012 and the experiment number 4 where again concentration of A is constant, right, 0.012. Now in these two trials, B concentrations doubled and rate got increased, 0.1 to 0.8 means 8 times. So what is that power when concentrations doubled? So let me write like this. So I have here R equal to, so R is proportional to B, right? So concentration of B to the power y, as we know. Now what are you supposed to do? We have to double the concentration. So to B to the power y, rate how many times increased? 8 times. So this is nothing but 2 to the power 3. So y is equal to 3. Immediately we got to know what is the power of concentration term of B, that is 3. So expressions, rate law holding for this particular right value is C and A. Let us figure out what is that power x. For that you go for the same method where concentration of B in first and third trial constant, right? So A concentration got doubled but rate didn't change. What does it mean? Zero order. Am I right? So therefore x is equal to 0, y is equal to 3. Anything to the power 0 is 1. So therefore R equal to k into B to the power 3, and right option is option A. Fine. The next one. Okay, I'll move to the next question. Here it is. For for an exothermic reaction, the energy of activation of the reactant is less than the energy of activation of products. How do you prove that? What is the method? Put a graph, isn't it? So you have studied the graph of potential energy against the reaction coordinate, and when you draw this graph, and it is a bell-shaped curve as we know. Now the exothermic reaction, therefore we can note down the activation energy. So this is the activation energy, right? So this is activated state which we learned as threshold energy, minimum energy required for the reacting molecules, and this gap what is there is delta H. So the energy of the product, energy of the reactant. So difference between product and reactant energy is delta H. So which is negative, higher value is reactant, lower value is product. So delta is negative, so which is for exothermic reaction, right? Same graph for endothermic, you have learnt it in theory. In last class we have drew that graph. Okay. Now it is asked for the reverse reaction. So reverse reaction start from here, you see. So therefore it's obviously less than the energy of the activation of products. So this EA is smaller compared to newly obtained EA, that is EA dash. Let me write it. So EA is less than EA dash. Therefore, option B is the right choice for this question. Fine. So the next one. Yes. A chemical reaction is catalyzed by a catalyst X, hence X does not affect the equilibrium constant for the reaction. We have learned the characteristics of activation energy, right, or catalyst, right, characteristic of catalyst. What is that? It doesn't alter the delta H value, it doesn't alter delta G, free energy also will remain same. So, and also the equilibrium constant will not get affected by the addition of catalyst. So therefore, again the right option is D for this. So I will opt option D for this. Yeah. Next, fourth question. Will you go to the fourth question? What is the answer for that? Just go through it. A substance A decomposes, right, by a first order reaction starting initially with the concentration of A is 2 molar. So initial concentration, what we have learned in theory as R naught is given, that is 2 molar. After 200 minutes A becomes 0.15 molar. So R is also mentioned. For this reaction, half life is, so how to calculate half life? We have a formula for it. T half is equal to, since it is a first order, T half equal to 0.693 by K. So K value is not given, you get the value of K using integrated rate equation method. So two formula will come in this problem. So let us go to that. Yes. So here it is, initially K is equal to 2.303 divided by, tell me, half life, time taken T into log of R naught by R. R naught is A here, so it is 2 molar divided by, right, 0.15. So that, as you told here, I will substitute time, right, 200 minutes. Let the answer be in minutes because options all are in minutes, so no issue with this. Now how to simplify this? You make this as 2.303 divided by 200 log, I will make this as 200 by 50, right. So this is log 200 divided by 15. Simplify this. K. What else you have to do here next? Once you get the K value, go to the half-life formula. What is the formula? T half is equal to 0.693 divided by K. So you will get the answer for half-life which is asked. How to simplify this? 540 is a, right, 5 3 is a. So that is equal to 2.303. At a time you substitute there, okay, or simplify. Divide by 200 into, I will write log 40 as log 4 plus log 10. Log 10 is 1, 1 plus log 4 is 0.6, so 1.6 value numerator. Denominator log 3, 0.477, so I will write 0.48. So the 1.6 minus 0.48, 477, so I will write as a 0.48. Now this difference, you know, 1.12, right? So the difference is 1.12, put there in the equation. What I will do is I will simplify that 0.693. So this is told as 0.693. I will write 2.303 into 0.3010, so that I can cancel, right, that 2.303. So I have in the denominator 2.303 divided by 200 into 1.12. So this cancels out, right, 200 will come to the numerator. So it's 0.3, let me write that, into 200 divided by 1.12. That will do. Approximately, I mean options, there are different options with a lot of difference, right, between the values, so you can opt it now. So what do you do? 0.3, right, you write this a 11.2, so 12, this is 3, 3 ones are 3, 4s are 12, right? So 200 by 4 is 50. You have to get that answer nearby 50. In fact, is more than 50 because you have got two answers there, two options. It's more than 1.12 it is, or 11 point, it's not exactly 12. So your numerator is less, therefore overall value has to be, denominator is less, so overall value has to be more. So more than 50 you have to get, that only one answer is there, option A, done. That skill you are supposed to have. Don't carried away with the answer 50 you are getting, so directly you don't opt it as option B, right? Denominator you have increased from 11.2 to 12, so your overall value will be more than 50. Fine. The next one, the rate of reaction depends on, simplest one, right? CET type, concentration of the reactant. Am I right? Yes. So it's not only volume or not only with the pressure. Of course, it's a partial pressure. Number of moles by volume, then it's fine. Number of moles by volume is called as concentration. Therefore, concentration of the reactant. Moreover, volume of what? They have not mentioned it. Volume of pressure, product doesn't matter there. Volume of the reactant to be taken. So you're supposed to know why the other options are wrong. Fine. Next, let us go to the other one. Question number 6. Okay. In a reversible reaction, the energy of activation of the forward reaction is 50 kilocalorie. The energy of activation for the reverse reaction will be, forward reaction it is 50 kilocalorie. The reverse reaction is asked. What is your take? Can I say directly less than 50 kilocalorie? No. More than 50 calorie? That's also not possible with 100% right surety. Whereas 50 kilocalorie, don't know, right? So the right answer is B. Either greater or lesser than the 50 kilocalorie. So what factor which decides which is greater or lesser than the 50? Whether the reaction is end or exo. We have a formula, right? We have written it. Delta H we can add or we can subtract from the forward activation energy. So therefore, we had this, I think, EA dash equal to EA plus or minus, right, delta H. So you have to add the delta H value if it is a exothermic reaction, because reverse reaction is going to be difficult, and you have to subtract when it is a endothermic reaction. So either of the two ways, fine. Next, the plot of concentration of the reactant versus time for a reaction is a straight line with a negative slope. The reaction follows zero order reaction, isn't it? So the plot of, let me draw here, the concentration, let me take it as R versus time is a straight line with a negative slope. So negative slope, the graph will be like this, and it is for zero order. Suppose if it is log R is given or mentioned, then it's a first order reaction. The same nature of the graph you are going to get, but it is log R to be considered. Fine. What about the next one? Here it is. Activation energy of a chemical reaction can be determined by evaluating the rate constant at standard temperature, evaluating velocities of reaction, nothing but rate of the reactions at a standard temperature, evaluating the rate constants at two different temperatures, and changing concentration of reactants. Which one do you think? It is option C. We have a Arrhenius equation where T2 minus T1 by T1 T2, right, log K2 by K1 equal to, thereby option C is the right choice for this 8th question. Okay. 9th one, half life of a first order reaction is 4 seconds and the initial concentration of the reactant is 0.12 molar. The concentration of the reactant after 16 seconds is, how to solve? Which formula to be applied? Did you understand the question? Half life is mentioned, right? Overall time they have mentioned. So what amount of the substance remains is the question. So we had a shortcut formula, if you remember, in the synopsis part, right? Amount of substance remaining after n half lives is equal to x, which is equal to, you are right, R naught divided by 2 to the power n. This point to be taken, where n is the number of half lives. Correct? How to find out n? Yeah. So n is equal to total time, which they have mentioned 16 seconds, divided by half life of, right, a reaction which is 4, so it is 4. So once you get that n value, R naught is given 0.12, right? You can compute it. So therefore the x is equal to 0.12 divided by, is that right? Correct na? 2 to the power 4. So this is 0.12 divided by 2 to the power 4 is 32 or 16. It is 16. Good. So you change that, make it as 16. Yeah. Now you can option A. Good. 0.0075 molar. Next. In the following reaction, how is the rate of appearance of the underlying product related to the rate of disappearance of the underlying reactant? What is the connection between the, see, underlying reactant is bromide 5 moles and that of the product is 3 moles of bromine. You write a differential rate law for the entire reaction. So what is that? Minus d by dt of BrO3 is equal to minus 1 by 5 d by dt of bromide, right? That is equal to 1 by 6 d by dt of H plus ions, and that is equal to product side. Now positive sign to be taken, 1 by 3 d by dt of bromine, that is equal to 1 by 3 d by dt of water. So you figure out the right answer over the option D. Good. Option D, the right choice. Next, interesting question. When a biochemical reaction is carried out in laboratory in the absence of enzyme, then the rate of reaction obtained is 10 to the power 6 times, minus 6 times. Then activation energy of the reaction, the presence of enzyme is, so is in the absence of enzyme it is less. You know that enzymes are biocatalyst. So when catalyst added, rate of the reaction has to increase. So in the absence of that enzyme it is lower or less, whereas in the presence it is going to be increased, right? To what extent it increases, we need to have some data to, right, find out it. Arrhenius equation we have to go for it, right? So here 6 by RT we cannot predict it, right? P is required, pressure is required. I don't think so, because there is no pressure term in the case of Arrhenius equation. It is K is equal to A into e to the power minus EA by RT. So therefore it is not told. Can't say anything. Better option, different from EA obtained in laboratory. That is for sure, right? So therefore right answer is, or in this situation the right answer is option B. So select option B for this question. Definitely you can say something, because when catalysts are present, activation energy is going to get lowered, right? Next, 12th one. For the reaction 2N2O5 giving 4NO2 plus O2, the rate and rate constants are 1.08 into 10 raised to minus 4 mole per liter per second and 3.4. So you are provided with rate R, so R is given, and K. So what is the R value? It is 1.02 into 10 to the power minus 4. Okay. What is the rate constant value? K is equal to 3.4 into 10 to the power minus 5. Now the concentration of N2O5 is, okay, so we have a basics of this kinetics. R is equal to rate constant K, good, into N2O5 to the power what? 1. Why did I select 1? Because the order of the reaction I evaluated by looking into the unit of the rate constant. Per second unit for rate constant is for first order reaction. If you dub in 0 order, then mole per liter per second. Second order, liter per mole, right, per second. So therefore I am very sure that this reaction is a first order after observing the unit of the rate constant. So this is it. Now take the ratio, that's it. You are given with R, you give it K. Can't you find out what is N2O5? Yes. do that. So the option is B, right option is B. Next, in the reaction 3A giving 2B, the rate of reaction plus d by dt of B is equal to, so I think this type of questions now you are able to do, right? So it's option B. So equate that, no? The others who didn't follow this, just you write minus 1 by 3 d by dt of concentration of A is equal to, yeah, plus 1 by 2 d by dt of concentration of B. You know what is the significance of plus and minus sign? Decreases, I mean the concentration of the reactant decreases with the time, whereas this is a increase in the concentration, right? So therefore plus and minus sign. Now it's told dB by dt. So dB by dt if I want to have, then I have to get this, right, instantaneous term, I mean stoichiometric coefficient to the other side. So it is 2 by 3 minus sign, okay, 2 by 3 d by dt of A. So therefore right option is option B. Yes. Next, 14th one, 3A giving B plus C, it would be a zero order reaction when, read the options one by one. A, the rate of reaction is proportional to the square of the concentration of A, zero order, right? Then the rate of reaction remains same at any concentration of A. I think that is the one, right? Because according to definition of zero order reaction, the reaction rate should not depend on the concentration of the reactant, and that is told in the option B. So therefore right choice is option B. Okay, next one, I think it is visible. The temperature dependence of the rate constant K of a chemical reaction is written in terms of Arrhenius equation. A is equal to A into e to the power minus EA by RT. Activation energy of the reaction can be calculated by plotting. So it's asked 2-3 times in almost all the other competitive examination as well. Last year JEE also we had this question about the plot of log K versus 1 by T or ln K versus 1 by T. So one of the most important question in almost all the competitive examination. Fine. So what is the answer? Yes. So here we have option D, log K versus 1 by T, or it could be ln K versus 1 by T, which is not found here in the options. So I can go for directly. Yes, this is it. Next, if the rate of the reaction is equal to the rate constant, the order of the reaction, board exam almost 6 times in MCQ board examination, it is a B, right, zero order reaction. Good. Such a easy one. Next, the activation energy for a simple chemical reaction A to B is EA in the forward direction. The activation energy for the reverse reaction is can be less or more depending on the type of reaction, right, end or exo. Based on that we can fix it. So here also the option D holds good. Next, this one we have to work it out. The reaction A to B follows the first order kinetics. The time taken for 0.8 mole of A to produce 0.6 mole of B is 1 hour. What is the time taken for conversion of 0.9 mole of A to produce 0.675 mole of B? I mean, 2 different data were given, or at least 2 different concentrations were mentioned, right? So what actually we need to do, you tell me? What time taken, time calculation it is, first order, so it is right, integrated equation. So let us write 2 reactions now, or 2 equations at least, can do this, right? So the reaction is A to B, A to B. So initial concentration, if I fix it as 0.8 mole, what they are telling is, right, product formed is 0.6. So time taken for this is 1 hour it seems. Try to understand what is actually the problem here, right? Next, at the same time, if I start with the 0.9 let me write here below the A 0.9 mole, I have to have 0.675 mole of B. Now what is this time required to such a conversion? Fine? Yeah. So product concentration, since they have given, right, we don't have formula related to product. It is R naught by R in first order integrated form, right? R naught is given 0.9 and 0.8, two different cases, but R value they have not given, but product they have told how much it is to form. So what is actually the remaining reactant concentration? Original minus formed product. If you do that, the remaining A you will get it. So therefore, how much of A remains means 0.8 minus 0.6. Out of 0.8, 0.6 got converted, right? So remaining is 0.2. Similarly, you can do here. So K value is not given. Therefore, two equations will write. We will cancel K. Then we can find out the time, isn't it? So that's how it has to be. So you see here, K is equal to 2.303 divided by time, which is 1 hour. They told, right? Log of initial concentration of 0.8. Now 0.8 minus 0.6. Am I right? 0.8 minus 0.6. Yes, the first equation. Let us go to the second equation. What is that? Also, in the second case, we are starting with some other initial concentration 0.9. So we will write that K is also is equal to 2.303 divided by that time. We have to find it out. Let it be T log of initial concentration of 0.9, remaining is 0.9 minus converted 0.675. Now you can compute it. Equate these two, K get cancelled, so time could be found out. Or in place of this K rate constant, you substitute this. That is also fine. So shall I proceed? So it is 2.303 divided by 1 log 0.8 by 0.2 is 4, log 4. Log 4 value is known. So shall I write directly? Yes. So it is 0.6. Yes. Next, that is equal to 2.303 divided by T log 0.9 divided by 0.225. 0.225. Double of it is 0.45, 4 times of it is 0.9, again the ratio will be 4. So log 4 is again 0.6, isn't it? So everything get cancels, so T equal to same 1 hour. So the right answer is option B. Next, the 19th one. The rate of a first order reaction is 1.5 into 10 to the power minus 2 with a unit at 0.5 molar concentration of the reactant. The half life of the reaction is, yes dear students, you can work out this problem, isn't it? The rate of first order reaction is given, R is known, then the concentration is known. Can't you get K? Because R is equal to K into concentration to the power 1. So with that you find out what is K for this rate constant, then half life is easy, right? 0.693 by K. So do that quickly. Yeah, many of you have done this, right? Or perhaps all of you. Good. So it is option A or B? B. Good. So for others it is R is equal to K into concentration of the reactant, let it be R. So I have K is equal to R value as 1.5 into 10 raised to minus 2. The concentration is 0.5. So this is nothing but 3 into 10 to the power minus 2. Hope that is right. Next, T half is equal to 0.693 divided by K. So this is 0.693 divided by 3 into 10 to the power minus 2. I'll write 69.3 divided by 3, because 10 raised to minus 2 will become plus 2 in the numerator. So 69.3 divided by 3. So 23.1 minute. So right option is B. Okay then. So Next target is 20th question. For a first order reaction A to B, the reaction rate at a reactant concentration of 0.1 molar is found to be so much. The half life period of the reactions. Once again, calculation related to half life, right? So I think the same method. Is that right? Option D. Good. So you have rate 0.01 at molar concentration as 2 into 10 raised to minus 5. Quickly improve your skill, improve the speed of solving the question. So R equal to K into concentration of the reactant. K is equal to R value 2.0 into 10 raised to minus 5 divided by the concentration 0.01. Take it as 10 to the minus 2, make it as plus 2 in the numerator. So 2 into 10 raised to minus 3, right? What next? T half is equal to 0.693 divided by 2 into 10 raised to minus 3. 693 divided by 2, half of 693 is 347 point, right? Done. So option D, as you rightly said. Next, for the reaction 2A plus B giving 3C plus D, which of the following does not express the reaction rate? I think now it is your cup of tea, isn't it? So the right option is option B, D. Good. Option D is the right choice. You can minus 1 by 2 d by dt of A is equal to minus 1 d by dt of B, that is equal to 1 by 3 d by dt of C, that is equal to d by dt of D. So now we can interconnect those things. Option D is the right choice. The next question, 22nd one. The reaction hydrogen and iodine monochloride is represented by the equation. So here is a main reaction or overall reaction, H2 plus ICl, right? Iodine monochloride, it is ICl, giving HCl plus I2. Free iodine is going to get liberated. Fine. This reaction is a first order. So is the experimental proof is the first order reaction. They have figured it out. Now in hydrogen and also first order in ICl. So with respect to both these two reactants, the first order according to them. But if you look at the stoichiometric coefficient, it gives total order as 3. That is not the case. It is the experimental factor we discussed. So which of the proposed mechanism can be consistent with the given information about the reaction? So mechanism of the reaction, right? Slow and fast step. There will be two different steps if it is so. So first type or the pathway what they have given is mechanism A, H2 plus 2 ICl giving 2 HCl plus I2 it seems. And if you see the path A, right, only one step, single step. So in a single step reaction or otherwise known as elementary reaction, stoichiometric coefficient sum itself supposed to be order. So should have been third order overall. With respect to H2 order is 1, that is perfect, but with respect to ICl also it should have been first order reaction, but it is second order, right? Given is first order, but if you take the stoichiometric coefficient it will be second order. So this is the wrong path, right? What about the second one? It's two step. First is a slow step. In that only 1 mole of ICl is present. So your stoichiometric coefficient itself is order. So I can select this only mechanism B and option D, B only. Fine. Next, if 60% of the first order reaction is completed in 60 minutes, 50% of the same reaction will be completed approximately. See, actually 50% of the reaction means half-life period, right? Half-life period of that reaction. To calculate half-life in a first order reaction, you are supposed to know the value of K. Is that right? So K value we can find out. How? The data is given. 60% is completed in 60 minutes. So time is given. R and R naught could be obtained with that information. So one can find out what is the K value. Once you get that, take the second step. So here it is how to solve. In theory also we have worked out such type of numericals. So we have K is equal to 2.303 divided by time 60 minutes log of 60% completed. So starting from 100, right, divided by 60% got over, so remaining is written 40. Good. So that is equal to, cancels out, so 2.303 divided by 60 into log 10 is 1, log 4 mean log A minus log B, log 4 is 0.6, so remaining is 0.4. Okay, next, the second half of this problem is calculation of the half-life, because 50% completion means half-life of its this reaction. So T half is equal to 0.693 divided by, I'll put K directly, 2.303, right, into 0.4. This denominator will go to numerator as 60, and moreover you know how to split this 0.693, right, 2.303 into 0.3. This value is nothing but 2.303 into 0.3010. In half-life derivation we have seen this, so that I can cancel out this 2.303 term. Next, easy it is, right, 0.3 into 60, 18, am I right, 18 divided by 0.4, 180 by 4, right, 4 4s are 4 5s are 45 minutes. Is there? Yes, option A. So only these types of problems we will be observing. Next, for the reaction N2 plus 3H2 giving 2 NH3, right, d by dt of NH3 is so much, the value of d by dt of H2, what does it indicate? Rate of disappearance of hydrogen. This is rate at which ammonia is going to get formed, rate of appearance of ammonia. So this appearance is given, disappearance asked. Only thing is that you have to interconnect, right, rate to be expressed in terms of reactants and products. It could be expressed. So shall we? So write that as I want to have hydrogen rate and ammonia. How these two could be interconnected? Minus 1 by 3 d by dt of H2 is equal to plus 1 by 2 d by dt of NH3. That's over, isn't it? Is that right? Yes. So I want to calculate this. So retain minus d by dt of H2 in the left hand side, take that 3 on the other side. So 3 by 2 times. So this is nothing but 3 by 2 into d by dt of NH3 is mentioned, 2 into 10 to the power minus 4. So 2 get cancelled. Option good, D. Next, 25th one. Let me display that question. Half-life period of a first order reaction is 1386 seconds. The specific rate constant of the reaction, NCERT exemplar question it is, and even it's there in the in-text. Okay, so many times asked in competitive as well as in the board exam. Specific rate constant means specific rate in the sense rate constant itself. Okay, so K is equal to 0.693 first, since it is the first order, divided by half-life, which is 1386. Make this a 693 into 10 to the power minus 3, divide by 1386. 1s are 2s are, 1 by 2 is 0.5, 0.5 into 10 raised to minus 3, 5 into 10 to the power minus 4 if it is there. It is given, no? Yeah. Option is not there, is there? D. Good, D. Next, for the reaction A plus B, there are few more reactions are going on, right? For the reaction A plus B giving products, it is observed that on doubling the initial concentration of A only, the rate of the reaction also doubled. This is what the observation is, right? And on doubling the initial concentration of both A and B, there is a change by a factor of 8 in the rate of the reaction. The rate of this reaction is given by, rate law is asked. They have told how concentration change varies the right speed of the reaction with respect to individual reactant. Can you find this possible, right? So first one, on doubling the initial concentration A only, the rate of the reaction doubled. So power is 1. Doubling the concentration of A. So let me write here R equal to K into A to the power 1 and B to the power 1. No, we can't fix it as 1, right? So what we have to do is we have to take that as some unknown else, isn't it? So R is equal to K into A to the power of X and B to the power of Y. Now it is right. Okay. So now on doubling the initial concentration of A, now you can calculate in mind itself, right? A, the rate got doubled. So 2 is proportional to 2 to the power X. So X equal to 1. So this implies, first statement here it is, right? This implies X is equal to 1. What next? On doubling the initial concentration of both A and B, so 2 to the power X and 2 to the power Y, rate changes by 8 times. So second sentence, let me write here, okay? Second sentence says that it 8 times increases on doubling both the concentration of A and concentration of B. So I can write 2 to the power 3 is proportional to 2 to the power X plus Y. So that indicates X plus Y equal to 3. Total order is 3. Already X is 1. So therefore Y has to be 2. So A to the power 1 and B to the power 2. Option A. Good. We'll move to the next one, 27th. Straight away I have taken PYQ from NEET. Okay, so 27th is a PYQ question which appeared in NEET examination. For the reaction N2O5 giving 2NO2 plus half O2, the value of the rate of disappearance of N2O5 is given as so much. The rate of formation of NO2 and O2 is given respectively. So they have interconnected that differential rate law and the calculation related to it. So how do you approach to this problem? Write the differential rate form quickly. Write the differential rate form. So for this reaction I have minus d by dt of N2O5 is equal to 1 by 2 d by dt of, tell me, NO2, that is equal to 2 into d by dt of O2. Now it could be solved. Rate of disappearance of N2O5 is given and is asked about NO2, formation of NO2. Let us write those two, formation of NO2 and this, right? So 2 times of it, isn't it? No need to calculate. D by dt of NO2 is asked, formation. So rate of formation, it's not instantaneous rate. I think we discussed about it, isn't it? Instantaneous rate, when you say stoichiometric coefficient should come. Rate of formation, disappearance, when we speak, then stoichiometric coefficient shouldn't be there. So thereby it is d by dt of NO2 is a rate of formation of NO2. So take this 2 to the other side, 2 times that of the given value. So 6.25 multiplied by 2, right? 12.5, which is nothing but 1. They have varied the 10 to the power. So here it is 1.25 into 10 to the power minus 2. Fine. The other one you verify it. It is oxygen, right? About oxygen. So it should be divided by 2 now, because you want to have only d by dt of O2. So take 2 to the other side. It will become 1 by 2. The given value is 6.25. Divided by 2 is 3.125. Here it is. So option B. So once you write the right relation, then you will come to know. Need not solve always. Yes, now it's about the 28th problem. 28. The rate of the reaction 2NO plus Cl2 giving 2NOCl is given by the rate equation. So rate equation is mentioned over there. The value of the rate constant can be increased by. So many times I used to tell in the class, rate constant is a constant at a constant temperature, right? It depends only on temperature. Further we studied even catalyst to change, addition of catalyst can change this. So thereby if you look into the options, only temperature effect it is. So option, which one is that? Increasing concentration, it doesn't help. Increasing the concentration, Cl2 also will not help. So only increasing the temperature. So option B, yes, you are right. Option B is the right choice. We'll be looking 29th one now. Which one of the following statements for the order of the reaction is incorrect? Incorrect statement is asked. Order can be determined only experimentally. Perfect, right? Order is not influenced by the stoichiometric coefficient of the reactants. No, only experimental, right, value to be seen or to raise it as a power. So therefore that is also 100% correct statement. Order of a reaction is the sum of the powers of the concentration terms of reactants to express the rate of the reaction, right, or experimental rate equation. So thereby this is also right. Fourth has to be the answer, right? Order of a reaction is always whole number. No, we have a fractional, we have a negative, right? Fine. It could be 0 also. Next, the rate of the reaction 2N2O5 giving 4NO2 plus O2 can be written in 3 ways. Okay, they have given how to express these rates in 3 different ways. The relationship between K and K dash and between K and K double dash are. I think it's simple, isn't it? You substitute for individual appearance and disappearance of reactants and products, isn't it? So we write a rate equation for this, then you substitute for this. Shall I? Yeah, here it is. See, the rate expression for this in differential form is minus 1 by 2 d by dt of N2O5 is equal to 1 by 4 d by dt of NO2, that is equal to 1, okay, it is just d by dt of O2. Hope this is fine, right? You understood how to write it. Fine. What next? Minus d by dt of N2O5 is so much. So put this here. So I have a stoichiometric coefficient as it is. So it is 1 by 2 into minus of d by dt of N2O5 is k into N2O5. You understood now, right? Next, I have d by dt of NO2 is k dash into N2O5. They have written all these in, right, differential rate in terms of N2O5 concentration. So let me substitute here 1 by 4 into k dash, right, k dash into N2O5. Finally, that is equal to last one k double dash into N2O5. Dear students, N2O5 is common, so get cancels. So I remain with this. I'll write here k by 2 equal to k dash by 4 is equal to k double dash. Next is simple, right? Right? Here it is 2k. This is k dash is equal to 4k dash. So which is that option? K dash, right? 2k, option B. Done. One more simple question, 31st. Option A. Unit of rate constant, first, second and third order along with the 0 order. So these 4 different order reactions, rate constant, better to know directly, so that you can save time. Otherwise you have a formula, you can right, derive that. Next, activation energy EA and rate constant K1 K2 of a chemical reaction at different temperature related by direct formula they asked. You definitely, if you go to PYQ, you will witness such type of direct questions also, right? So we have the right answer as D. A, ln K2 by K1 equal to, is it minus EA by R? How come A? Ln K2 by K1 equal to EA by R, it should have been, right? I have, can't you see this negative sign? Yeah. Next, B, is it possible? It should have been 1 by T1 minus 1 by T2. So this is also wrong. Ln K2 by K1 equal, again negative term is there, right? This is a problem. So option D, I think fine. Ln K2 by K1 equal to EA by R, 1 by T1 minus 1 by T2. So when you take the right LCM, then it is T2 minus T1 by T1 T2. So that's a perfect option D supposed to be the answer. Problem is here only negative sign, otherwise you would have been selected that as well. Okay. To be solved. What is the activation energy for a reaction if its rate doubles when the temperature is raised from 20 degree to 35 degree Celsius? R value is given. So calculation of activation energy, very important for board exam as well. Directly from NCERT, right? Exercise question. So it will be asked, and it was asked a few occasions in board examinations. So how to work out this problem? Arrhenius equation to be considered. So log of K2 by K1 equal to activation energy divided by 2.303 R into, you are right, T2 minus T1 by T1 T2. Now K2 by K1, they told rate doubles, so I will take this as a 2x and the initial one is Ax. So what remain with the log 2, correct na? Log 2 into, I will get these on the other side, 2.303, 8.314. I am substituting for R now. I took this to the left hand side. Denominator T1 T2, T1 value is 20 degree, convert into Kelvin, right? 273 plus 20, 293 into 35 degree, 308, good, 308 divided by T2 minus T1, because my intention is to calculate EA. T2 minus T1 is 35 minus 20, or even in Kelvin scale you can subtract, the difference will remain same, 15. Done. Log 2 value is known, 0.3. Can't you simplify this? Yes, you can. And the answer is option B. Straightforward question, was asked a few occasions, so answer is simple, 34.7. You will get approximate 35. You can now select the option. The product could be taken as 20, as I always mentioned, right? Then you decrease this to 300, increase this to 300. That will do. 293 plus 7 means 300. You decrease this by 7 or 8, approximately remains same. So 300 into 300 into 20 and 0.3 divided by 15. So 35 you will get answer. 34.7 is the exact one. What next? 34th one. A reaction is 50% completed in 2 hours and 75% in 4 hours. The order of the reaction is 50% in 2 hours means half life. 75% means 2 times the half lives. That means half life remain constant. It is not changing with the concentration. So which order? First order reaction. Half life is a constant with respect to initial concentration, is a first order reaction. So I can write like this, 100 if I have moles, I mean to say, so it will be 50 in 2 hours it seems, according to the sentence. That will become 25 in next 2 hours. What they told is total 4 hours, right? So from here to here 4 hours. That means half life is constant and is not depending on the concentration. First order reaction. So option B. Yes, go to the 35th one. For a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. The concentration of both A and B are doubled. The rate will increase by a factor of 32. So just you see here, A is 2, order with respect to A is 2. If I double it, 2 to the power 2 times 4. Then B is 3, 2 to the power 3 times 8. 8 into 4 is 32. So therefore it is 32 times the right answer. Option D for 35th. For the reaction of 4A plus B giving 2C plus D, which of the following statement is correct? The rate of formation of C and D are equal. You cracked it. The rate of formation of D is 1/2 of the rate of consumption of A, I think you write a differential form, you will come to know the right answer is, need not explain much, it's C, right, it's C. Shall I write that? -1/4 d by dt of A is equal to minus d by dt of B, that is equal to 1/2 d by dt of C, that is equal to d by dt of D. This is what the differential rate equation for this reaction. Now you can look at those options and you can select. Fine. T50 means half-life of a first order reacts 10 minutes starting with the 10 mole per liter, rate after 20 minutes is. So very interesting question. I think in the other classwork paper we have worked out same type of it, isn't it? Okay, let us solve this problem. Start. They told 50% of reaction is going to complete in 10 minutes, right? 50% of the reaction is completing in 10 minutes. So you can calculate K. Once it is known, starting with the 10, initial constant is 10, rate after 20 minutes, rate is asked. We have a formula for rate, R is equal to rate constant into concentration of the reactant. Hope I am right. So therefore, K value once if it is revealed, you can find out what is the R. How? R equal to some K value into R is given. Starting with the, no, R has to be found out. Both these two terms are not there in the question, right? Since half-life is given, K could be obtained and other information is mentioned there, one can find out with the K, R naught, R could be obtained with the right time. So do this in the following pattern, right? So I'll start with the K. What is K? K is equal to 2.303 divided by time is mentioned 20 minutes, log of R naught is given 10, R to be found out. So there are two unknowns in fact, R and K, but we can find out what is K with the help of half-life. So K is equal to what? 0.693 divided by T half, 10. That is equal to 2.303 divided by 20 into log 10 by R. Get me the concentration of R now. Solve this. So 10 ones are 10 twos, right? So this how to split, you know it. So shall I? 0.3010 into 2.303. 0.693 could be written as. So 2.303, 2.303 cancels out. So I have 0.3. You students observe 2 is in the denominator, so it's multiplication, right? So 0.6 it will become 0.6020 is equal to what? Log of 10 by R. So now what is 10 by R? Anti-log of 0.6. What is anti-log of 0.6? 4. Log 4 is 0.6. So anti-log of 0.6 is 4. So therefore you have 4 is equal to 10 divided by R. So R is equal to 10 divided by 4. It's 2.5. So you got to know what is the concentration of the reactant, 2.5 molar. Through that, remember, you have cracked the K also. How? 0.693 by 10 is 0.0693. So 0.0693 into 2.5 is a rate. Why it is so? Because you have a formula for rate, R equal to K into concentration of the reactant time T. So your K value is 0.693 by 10, 0.0693 into R value is 2.5. So option D. Let us try to complete the remaining. Okay. 38th one. The rate of first order reaction 0.04 mole per liter per second at 10 seconds and 0.03 mole per liter per second at 20 seconds after initiation of the reaction. So there is no initial concentration of the initial time which is mentioned about it. Somewhere in the reaction, in some stage they have taken this data. So the half-life period of the reaction is asked. See, all these things you should remember. Half-life period formula is T half equal to 0.693 by K. They have not mentioned about the K. So first work is to find out K, rate constant. And moreover, it's told it's a first order reaction. You have a formula for first order, right? So K is equal to, if you remember, we have written this formula as well if we don't know the initial concentration, right? Remember, T2 minus T1. I have given it as a note in the point book, right? So T2 minus T1 log of R1 divided by R2 at two different stages. R1 is higher concentration, R2 is lower after some time. So therefore you apply this and get the value K, no? So 2.303 divided by time difference 10 seconds and 20 seconds, right? So T2 minus T1, 20 minus 10, higher T2 minus T1 it is, right? So into log of R1 0.04, R2 0.03. Now you came to know how to work it out. Finished, isn't it? So simplify this, get the K value, put it in that equation. Will you? Later we will write that formula. Simplify that. It is 10. So 2.303 by 10 log 4 by 3. Log 4 by 3 by now, after solving so many problems, you might be knowing it. Log 4 is 0.6. Log 3 is 0.48. 0.12. Yeah. So this is nothing but K is equal to 2.303 divided by 10 into 0.12. Log 4 by 3 it is. 4 into 10 raised to minus 2. 3 into 10 raised to minus 2. Minus 2 get cancelled. 4 by 3. Log 4 minus log 3. Log 4 is 0.6. Log 3 is 0.477. 0.48 you make. Next it is easy. Am I right? So if I want to simplify this, 2.303 into 12 into 10 raised to minus 2, this will be one more minus 3. 12 into 10 to the power minus 3. Let it be, because we have 2.3 in term in our half-life expression. What to be done next? T half equal to 0.69 I'll write as 2.303 into 0.3 divided by this value 2.303 into 12 into 10 to the power minus 3. Cancels out. 3 ones are 3 fours are, right here it is 40 times. So write 10 to the power minus 2. Am I right? 10 to the minus 2. So 1 by 4, 0.25. 0.25 into 10 to the 2, 25. 24 point. See. I'll keep on reminding, calculation is or simplification is a skill, right? You should develop it. Next. The rate constant of a reaction changes when, so many times we have discussed it, temperature is changed. Option D. Same concept asked in different sentences, that's it. 40th one. The rate constant of a reaction is so much. If the concentration of A is 5 molar, then the concentration of B after 20 minutes. They have asked the concentration of B after 20 minutes. Any idea? Product is asked, in fact, right? They have told A to B. A to B. Concentration of A initial, condition I am talking about, 5 molar it seems. Nothing is remaining or formed at that time. So after certain time, right, 20 minutes, what is the product concentration is their question, right? What is the concentration of the product? To solve this problem, first of all we should know what is the order of the reaction, which formula to be applied, isn't it, in such cases. What could be the order for this? Zero order. How? Rate constant unit reveals it, isn't it, mole per liter per second. So it's a zero order reaction. For zero order, it's our favorite reaction, isn't it? Why? Formula is simple. So it is K into T is equal to R naught minus R. What is the question? How much product is formed, isn't it? How much product is formed? That isn't it proportional to how much A is remaining now, or how much A got reacted, right? Is that right? So how to find out reacted? So initial minus remaining is nothing but reacted, isn't it? R naught minus R itself is a B formed or amount of B formed. So you have to calculate this thing, dear students. R naught minus R is how much? That you have to calculate. So let me do that without working much. Here K is given 0.6 into 10 to the power of minus 3. Time is told 20 minutes. After 20 minutes, isn't it? 20 minutes. So into 20. Is that right? And 60 seconds if you want to convert that into 60. Done. Equal to, let me take this as a amount of product formed, X, because if I write 5 minus X, here formed will be X mole. So that's what asked. Simple now. 0.6, 20 into 60, so I will write 12,200, right? So 1.2 into 10 to the 3, that 10 to the 3 and minus 3 get cancelled, so 1.2 into 0.6, 12 6 are 0.72 molar. The answer is option D. Next, the rate constant for the reaction 2N2O5 giving 4NO2 plus O2 is so much. If start made with 1 molar of N2O5, calculate the rate of formation of NO2 at the moment of the reaction when concentration of O2 is 0.1 mole per liter. JEE type problem. Okay. Did you solve this? No. Let us see how to work out this problem. Okay, write a reaction first. What reaction is given for us? N2O5 gives 4NO2 plus O2. So this is 2N2O5. Initially, right, the concentration start is made with 1 molar they told. So it is 1 molar. No products could be formed at the beginning unless the reactant react. Next, calculate the rate of formation of NO2 at the moment when the concentration of O2 is 0.1. So after some time t, right, what remains here is 1 minus 2x, 2 times dx. What forms is 4x with respect to NO2. What about oxygen? X. Now you reread this question, calculate the rate of formation of NO2. We have to find out the NO2 rate when the moment is concentration of O2 is 0.1. So isn't it X equal to 0.1 they told? We have to find out the rate of formation of NO2 when the reactant concentration corresponding to oxygen is 0.1. So the X value is 0.1. Now we can solve this, isn't it? What is the rate formula? R equal to K into, right, concentration of NO2. This is what asked. K value they have provided. What is it? K equal to 3.0 into 10 to the power of minus 4. Now by knowing the X value, can't you find out the N2O5 concentration? No, before I will write N2O5 because reactant concentration it is depending on rate. Okay, N2O5, I am sorry, change it, N2O5, fine. So can you get the N2O5 concentration now? How much? 1 minus 0.2. How it is 0.2? 2 into 0.1, 0.2. So it's 0.8. So into 0.8. So I'll write here, this is 8 into 3, 24, 2.4, isn't it? 2.4 into 10 to the power of minus 4. Rate with respect to N2O5 I have cracked. This is it. But what is asked? Rate with respect to NO2. Now what are you supposed to do? See how many concepts are mixed in this question. Right? Initially equilibrium type of thing is asked. Then the basic of rate law. Once you do this, then differential rate form. Will you agree with me? Because N2O5 rate, if you come to know, you can interconnect with NO2 as well as O2. Minus 1 by 2 d by dt of N2O5 is equal to 1 by 4 plus d by dt of O2, sorry NO2. So get the NO2 rate now. That means d by dt of NO2 is asked. Read the question. Calculate the rate of formation of NO2 is a question. We can't directly calculate NO2 rate because rate depends only on the reactant concentration. Rate could be connected to the product concentration, but depends on reactant only. So first you reactant concentration rate you find out. Then you connect that to the other. So what next? Last step. Therefore, d by dt of NO2 equal to, please help me now here, 1 by 2 d by dt of N2O5, 1 by 4 it is, so 4 will come to the left hand side, so 4 by 2, so this is 4 by 2 into d by dt of N2O5. Is that fine? With a minus sign. Now what I can do here is, this 4 by this 2 into minus d by dt of NO2 is here, rate with respect to N2O5, right? Minus d by dt of N2O5 is how much? 2.4 into 10 to the power of minus 4, that is equal to 4.8 into 10 raised to minus 4. Such a work you have to do. So option C. One more different variety of problem asked in the competitive. Next, the rate constant for a first order reaction is so much. I think this is a direct one, right? Time required to reduce 2 gram of the reactant to 0.2 gram is, so R0 and R value, K is given. Can you get the time? Yes, do it. So T is equal to 2.303 by K. I think you came to know what is the formula. K actually, rearrange it, log of, right, R0 by R. So this is 2.303 divided by 4.6 into 10 to the power minus 3 into log of initial 2, final 0.2. So 10 times, log 10 is 1, it's vanished. So 2.3 by 4.6 is a half, right? 500 seconds. Option A, done. So many problems of this type we have seen. Directly I will give the answer, option C. Or A or B. The right option is, you didn't agree, right? You should not agree with directly. Which is answer? B? Yeah. What next? A reaction involving two different reactants can never be unimolecular. Minimum molecularity is 2, isn't it? So therefore option A is the right choice. Next, about collision theory, dear students. Collision theory is used to explain how chemical species undergo a reaction Using this theory and the kinetic molecular model, which of the following does not influence the rate of a chemical reaction? Temperature of the system, geometry of the orientation of the collision, the velocity of reactants at the point of the collision, or all the above influence the rate? All the above. Yes. So option D is a choice for it. Go ahead. So next. What next? NO2 plus CO2. Observe the reaction carefully. NO2 plus CO2 giving NO plus CO2. NO2 plus CO giving NO plus CO2. Okay. The rate law is rate equal to, this is what very important for us. What does it indicate? It depends only on the concentration of NO2, that to power 2, second order. Correct, no? Yeah. If 0.1 mole of gaseous carbon monoxide is added, does it matter the addition of CO2? No, right? CO or CO2, because it not is going to decisive factor or playing a decisive factor for rate. So you leave that, both K and the reaction rate remain same. It is irrelevant the concentration of carbon monoxide. Rate law you observe whether that term is included or not, that is a decisive factor now. Next, 47th one, C or A? C. Next, 48th one, A, right? A reaction which is a first order with respect to reactant A has a rate constant of 6 minutes. Okay, 6 minute inverse. If we start with the 0.5, when would A will reach the value of 0.05? And time is asked here, right? Time you have to calculate. So I'll give the formula, then you do it, the others, those who are watching, right? So time T is equal to 2.303 divided by K log of R naught divided by R. So now we have K value which is 6 min per minute, then log R naught is 0.5 and R is 0.05, is 10, log 10 cancels out. So my student's friend told it is A, it is right, right? Next, 49th one. Very important, one more type of problem, right? Hypothetical reaction is given, x2 plus y2 giving 2xy, right? And this reaction occurs in 3 different steps, as you can see here. x2 dissociate to give x, right, moles, so it is a faster reaction compared to second one. So x plus y2 giving xy plus y, slow, and the last one is also fast. And by definition, right, of complex reaction rate, you know that rate depends only on the slow step. Therefore R is equal to rate constant K into x to the power 1 and y to the power 1. Look at this slow step. Reactant concentrations power 1 each. So that's what we have written. Now in the main reaction, here it is, there is no term related to x. Atomic state of x2 is x, which is not included in the major reaction. So therefore it has to be substituted, and for substituting, right, we have talked the first one. So what is equilibrium constant from this? K equilibrium is equal to, right, product of product, x into x, shall I write x square divided by concentration of x2. So I can write what is x there. So concentration of x is nothing but K equilibrium into x2, right, whole to the power what? Half. Square root I have to take. Am I right? So x square equal to equilibrium constant x2. So x equal to square root of that. So let me resubstitute here. So this implies R is equal to K into, right, K equilibrium to the power half into x to the power half into y2 to the power 1. think that is the answer, isn't it? So now what is the order? Sum of the powers of the concentration terms. So these two are product of constant, another constant, that's it. So here half plus 1, 3 by 2 or 1.5, option C. Six questions more, right? So we'll complete this paper today. A first order reaction has a specific reaction rate of 10 to the minus 2 second inverse. How much time will be taking for 20 gram of the reactant to reduce 5 gram? Same type problem we have worked out, only the values are different. Here it is. Don't remember the exact question number. 2 gram to 0.42 question, and this is same, but data different. Please go ahead with that, right? The right answer is A, option A. Next, 51st. The correct difference between the first and second order reaction is that? Option D. A first order reaction can catalyzed, or B. The half-life of first order reaction does not depend on initial concentration. The half-life of a second order reaction does depend on, I'm sorry. Okay, so therefore option B is the right choice. If the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is simple, right? 99% and 99.9%, all these things could be asked in exam. So how to work out this problem? They told first order reaction rate constant is K. The time required for the completion of 99% of the reaction. We'll go with that, right? K equal to 2.303 divided by, let me write this is T 99%, log of R naught value, let it be 100, remaining 100 minus 99, 1. So question is about time required for 99%. So T 99% equal to 2.303 divided by K. Yes, log 100 is 10 to the 2. So it is 2 into log 10. Log 10 is 1. So therefore 2.303 into 2, 4.606 divided by K. Fine. So 50 second is done. Next, 53rd question. Okay, 53rd question. Option C. Good. Next. So many problems we worked out of 53rd type, so we do that. Next, 54th one. An increase in this concentration of the reactant of a reaction leads to change in. What is your take? Increase in the concentration of the reactant of a reaction leads to change in collision theory. Number of collision taking place per second per unit volume. When you increase the concentration, right, in unit volume, reactant molecules are going to be more, so collision will increase. That will lead to increase in collision frequency. So concentration if you increase according to collision theory, right, the collision frequency is going to increase. Next, last one. For producing the effective collisions, the colliding molecules must have key point of this theory, right? Proper orientation and energy equal or greater than threshold energy. So option D. That's it. So please go through the earlier uploaded classwork paper. Okay, consider that as a homework. Thank you.
A very good afternoon to all. Today we are going to deal with the topic dual nature of matter and radiation. So we have with the CET paper of this chapter. By solving each and every question, we try to reconnect to the synopsis of this chapter. Okay, first of all, what is photoelectric effect? As we know, when there exists a photoelectric vacuum tube for which we made to incident a light of energy h nu, then there are two electrodes. Basically, one is an emitter and the other one is a collector. So we connect a battery to this. In such a way that ಇಲ್ಲಿ ಒಂದು ಮೆಟಲ್ ಪ್ಲೇಟ್ ಇರ್ತದೆ, ಎಮಿಟರ್ ಅನ್ನ we even call it as a cathode as well. When light is incident on an emitter, then when each and every metals have a work function phi naught, if the energy of light incident is greater than the work function, what is work function? Work function is nothing but the minimum energy required to remove an electron from the metal surface. If a light incident has an energy greater than the work function, then the electrons are emitted from this. As the electrons are emitted, they are collected across the collector plate, also called as a anode. So this is a basic idea behind the photoelectric effect. Let me go for Einstein's explanation of photoelectric effect. According to Einstein's equation, we have maximum kinetic energy of a photoelectron is h nu minus phi naught, where h nu is the energy of photon and phi naught is the work function. With this equation, now we try to go for the first question of our paper. The maximum kinetic energy of photoelectrons is. Let me try to understand the options what I have. Independent of frequency of incident radiation. As we have an equation here, so itself have a clarity that the maximum kinetic energy of photoelectron depends upon the frequency. So independent of frequency of incident radiation is obviously wrong. Then depends on linearly on the intensity of radiation. Maximum kinetic energy depends on intensity of radiation. So here only we will get a clarity that maximum kinetic energy does not depend on intensity. Then it depends on the frequency of incident radiation. For sure, it depends on intensity of incident radiation. So option 2 is the answer. None of this, definitely not the answer. So by having Einstein's photoelectric equation only, we will get a clarity of this. Okay. Shall I proceed to the next question? The second question what we have, the frequency and intensity of light source are both doubled. Consider the following statement. Frequency and intensity of light source is doubled. Look into the two sentences what we have. First one is the saturation photocurrent remains almost same ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ನಮಗೆ ಈ ಸ್ಯಾಚುರೇಷನ್ ಫೋಟೋಕರೆಂಟ್ ಅಂದರೆ ಏನು ಅಂತ ಗೊತ್ತಾಗಬೇಕು. ನಾವೀಗಷ್ಟೇ ಬರೆದಿರೋ ಹಾಗೆ ವೆನ್ ಐ ಹ್ಯಾವ್ ಅ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ನಾವು ಹೇಳಿದ್ದೇವೆ. ವೆನ್ ಅ ಲೈಟ್ ಆಫ್ ಎನರ್ಜಿ ಹೆಚ್ ನ್ಯೂ ಇಸ್ ಇನ್ಸಿಡೆಂಟ್ ಆನ್ ದಿಸ್ ಎಮಿಟರ್ ಪ್ಲೇಟ್, when h nu is greater than phi naught, I will be having a photoelectric emission, and as we connect the collector to the positive potential, or we call it as this is a anode and this is a cathode, right? So naaniga idikke as I make this anode to be more and more positive, for sure ಇಲ್ಲಿಂದ ಎಮಿಟ್ ಆಗ್ತಾ ಇರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲವೂ ಕೂಡ ಆ್ಯನೋಡಿಗೆ ಹೋಗಲೇಬೇಕು. ಯಾಕಂತಂದರೆ ಐ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಕನೆಕ್ಟೆಡ್ ದಟ್ ಟು ದ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್. ಸೊ ಆಸ್ ಯು ಇನ್ಕ್ರೀಸ್ ದಿಸ್ ಪೊಟೆನ್ಷಿಯಲ್, more and more electrons are reaching towards the collector plate. Then how the photocurrent, what is photocurrent? Photocurrent is nothing but current due to photoelectrons. How the photoelectrons are emitted? Photoelectrons are emitted based on the intensity or based on the energy with which a light is incident on it. So if I plot the graph of photocurrent IPH, if I specify with the intensity, I can clearly say that as you increase the intensity, photocurrent also increases. Okay, let me come to the first aspect. Saturation photocurrent remains almost same. Let me have few clarity. Intensity of incident radiation is nothing but intensity. What is intensity? Intensity is nothing but number of photoelectrons or number of photons per unit area. Energy per unit area per time is intensity. Since I can multiply with the number also, then intensity is energy per unit area per time. So what is energy by time? Energy by time is anyhow power by area. So intensity is depends upon energy, area, or in general power, area. The first sentence what we have is the saturation photocurrent remains almost same. ಯಾವಾಗ ಅಂತ ಹೇಳಿದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಮತ್ತು ಇಂಟೆನ್ಸಿಟಿಯನ್ನು ಡಬಲ್ ಮಾಡಿದ್ರಂತೆ. ಸೊ ಫೋಟೋ ಕರೆಂಟ್ ಈಗ ಇಲ್ಲಿ ಇಂಟೆನ್ಸಿಟಿಯನ್ನು ಡಬಲ್ ಮಾಡಿದ್ದೇವೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಆಸ್ ಯು ಇನ್ಕ್ರೀಸ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಆ್ಯಂಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಸೊ ಐ ಕ್ಯಾನ್ ಆ್ಯಕ್ಚುಲಿ ರೈಟ್ ಎನರ್ಜಿ ಆಫ್ ಎ ಫೋಟಾನ್ ಆಸ್ h nu divided by A into T. In the question they have told that intensity is increased and frequency is also increased. Then the number of photon remains constant, right? Number of photons remains constant. How I get a clarity? Because they have told frequency was doubled and intensity was doubled. So that all these things are constant, so I can say n will be constant. So I have a clarity that the first sentence is correct. Let me come to the question, the sentence B. Maximum kinetic energy of photoelectron is doubled. Let me have a Einstein's equation. I have K max is equal to h nu minus phi naught. So they were saying that if I double the frequency, since the maximum kinetic energy is not at all be dependent on intensity, so let me take this as K1. Let me take K2 is the situation in which you have doubled the frequency. Then from this basically I can write h nu will be equal to K1 plus phi naught. Then what is K2? K2 is the kinetic energy when the frequency was doubled. That means h into 2 mu minus phi naught. 2 into what is h nu? H nu is K1 plus phi naught minus phi naught. So if I further rearrange, then I am getting 2 K1 plus 2 phi naught minus phi naught is nothing but 2 into K1 plus phi naught. What actually the clarity we are getting? The kinetic energy is doubled anta question allirodu, but we are actually having double the kinetic energy plus work function, so it is more than double. So I can say for sure option B or the sentence B is false. So which one is the answer then? A is true but B is false, so 2 is the answer. Okay, shall I proceed to the next question? If the frequency of light in a photoelectric experiment is doubled, the stopping potential will be. Okay, let me try to know what is stopping potential. So it's a minimum negative potential after which photoelectric emission or photoelectron emission stops. Let me try to write what is that stopping potential. How can I relate the stopping potential? So, like the situation, I want to try to give a clarity for you. Say we have a photoelectric tube, as I told, I have h nu and I have an emitter plate here, I have a collector plate. Let me try, I connect a negative potential for this. Just think of, if I connected a negative potential for a collector plate, then do you think the electrons will reach to a collector plate? For a certain potential, maybe possibility to reach to a collector, but since I have a negative connected to the collector, so the electron emission stops for a time being. Then that potential itself is called as stopping potential, the negative potential for which photoelectric emission stops. Then as we have an idea, kinetic energy equal to work done or change in work done from the work energy theorem only we have. So, what is maximum kinetic energy then for this case, since I have the work done is Q into V, which is nothing but E into V, and we specify V is a potential here, so I consider it as EV naught. So, maximum kinetic energy equal to EV naught, where V naught is a stopping potential. Let me coming to this question. If the frequency of light in the photoelectric experiment is doubled, what happens to the stopping potential? Frequency was doubled. So, I can actually relate this to the Einstein's photoelectric equation as K max is equal to h nu minus phi naught is what I have. So, EV naught is equal to h nu minus phi naught, or stopping potential is nothing but h by E mu minus phi by E. I just take it as phi. Okay, this is a stopping potential expression I have. Now, what I have told is, if the frequency of photoelectric experiment was doubled, if I double the frequency, let me take V naught dash, then h by E 2 mu minus phi by E. As I can simplify for h nu by E from this, h nu by E will be what? V naught plus phi by E. Am I right? So, I substitute that here. So, 2 into V naught plus phi by E minus phi by E. So, we are getting 2 V naught, 2 phi by E minus phi by E is plus phi by E. So, once again we are getting a clarity that the stopping potential is not just double, becomes more than double. So, that is why option 3 is the answer. Okay. Let me proceed to the next question. Two photons having equal wavelengths have equal linear momenta, equal energies have equal linear momenta, equal frequencies have equal linear momenta, equal linear momenta have equal wavelengths. Okay. The simplest way of analysis of a question is by looking into the scalar and vector quantities. Before going to that, this concept, this question is related to a concept called as de Broglie's wavelength equation. De Broglie told that about the wavelength of a matter wave as lambda equal to h by p. So, where lambda is wavelength, h is Planck's constant and p is momentum. So, here they are saying that two photons have equal wavelengths have equal linear momenta. It's a tricky question, like equal linear momenta. I can say linear momentas are equal only when they have equal magnitude, equal direction as well. So, deciding equal wavelength have equal linear momenta is difficult for me because it's a vector quantity, right. So, equal energies have equal linear momenta, even this is a scalar, this is a vector, maybe have a different direction. Frequencies have equal linear momenta, frequency is a scalar, equal linear momenta, maybe there is a change in the direction. That's why fourth one was a perfect choice for us. Why? Because equal linear momenta have equal wavelengths. They have specified equal linear momenta means magnitude wise as well as direction wise they were same, right? Magnitude and direction is perfectly same. That's why wavelength must be having same value. So the perfect choice is option 4. Then proceeding to the next question. Okay, a point source of light is used in a photoelectric effect. If the source is removed farther from the emitting plate or emitting metal, the stopping potential. As we have already written an equation for a stopping potential as EV naught is equal to h nu minus phi naught. So we are actually having a clarity that if I ask on what factors does the maximum kinetic energy depends, then for sure our answer will stick on to it depends on frequency and it depends on stopping potential. Work function. I'm real sorry. So mu and phi naught depends on maximum kinetic energy depends on the frequency and the work function. Then of course the stopping potential also depends on that, right? They were asking or they were saying in a question that if the source is removed farther from the emitting metal, let me try to understand, does the movement of the metal plate or the change in the distance affects to the stopping potential? Here we have a clarity that there is no dependency on that, but still we try to understand what may happen if the source is removed moved farther from the emitting metal. So basically intensity can be related to a distance. Let me try to relate that to a distance. How can I relate the intensity to a distance? Intensity is nothing but energy per unit area per time. So that is nothing but power by area. If the source is a point source, then we can actually say intensity is inversely proportional to area. For a point source for sure it is 4 pi r square, and I can actually say intensity is inversely proportional to a distance. Okay, intensity is inversely proportional to a square of a distance. Intensity varies means there is a variation of photocurrent may takes place. Can you say why? Why? Because as the intensity increases, number of photons emitted increases. Number of photons emitted increases means photoelectron also increase, right? Photoelectron increases, for sure photocurrent also increases. That's why I have already written a graph of photocurrent versus intensity. Photocurrent versus intensity graph we had. So it's a linear variation we have seen. Then here also we have a clarity that photocurrent may vary with the distance but not the stopping potential. Okay, ಇಲ್ಲಿ ಹೇಳಿರೋದಕ್ಕೂ ಅದಕ್ಕೂ ಏನು ರಿಲೇಟ್ ಮಾಡ್ತೀರಾ ಅಂತಂದರೆ, say for example we are plotting a IV characteristic curve. IV means photocurrent versus anode cathode potential. Then if by keeping frequency constant, if I keep frequency constant, then for sure stopping potential must be constant. So I have a nature of a graph something like this. Let me take I and 2I. That means I am changing the intensity by keeping the frequency constant. What is this? I will be having a constant value for a current, right? We call it as a saturation current. It's a maximum current after which it's a maximum current of a particular metal for saturation. So if you further increase the potential, there is no more increase in the current will be seen. So that kind of current is known as saturation current. Okay, what is this? This itself is a stopping potential. That's what we told. It's a negative potential, right? So stopping potential will be same if you vary the intensity of light by keeping frequency constant. So stopping potential depends on frequency. So I can actually say stopping potential will remains constant. Okay, then the sixth question. A non-monochromatic light is used in an experiment on photoelectric effect. Stopping potential. Once again we are relating the stopping potential here. What is this non-monochromatic? Monochromatic means a light source or light having a single wavelength. Non-monochromatic they have told, that means for sure I will be having a different wavelengths, right? Then of course I have a stopping potential equation to be as, or maximum kinetic energy as h nu minus phi naught. Then h c by lambda I can write, mu can be replaced as c by lambda minus phi naught or phi. So stopping potential, or in general if I write maximum kinetic energy, from that I can relate to a stopping potential. I have a relation something like this, right? Maximum kinetic energy is inversely proportional to the wavelength. As the wavelength of, to have a maximum kinetic energy, I should have a lesser wavelength, right? To have this quantity to be maximum, this must be lesser. That means maximum kinetic energy is for a shorter wavelength for sure, then the stopping potential is also related to the shorter wavelength. Then proceeding to the next question. The photon of energy h nu is absorbed by a free electron of a metal having a work function phi is less than h nu. That means energy of a photon h nu is greater than phi. I have for sure photoelectron emission possible, but look into the question carefully. Options what we have here, the electron is sure to come out. How can I say electron is for sure to come out? Because electron may reside inside the outermost shell, electrons may come out. I can't surely say electron will come out. Then second option, the electron is sure to come out with the kinetic energy of h nu minus phi. We basically write kinetic energy h nu minus phi. No, we basically write maximum kinetic energy is h nu minus phi. Electron is sure to come out. I can't say sure to come out. Why? Because electron have interaction with electrons, collide themselves, the electrons collide with the metal surface. So it is not sure that they will be having a kinetic energy of h nu minus phi. It may be less than that, right? So it may come out with the kinetic energy less than h nu minus phi is the right answer. You may have a doubt, why can't we go for 3? Either the electron does not come out or it comes out with the kinetic energy h nu minus phi. There is a ionization energy loss, right? So I can't consider the option 3. So the only possible answer or the right answer is it may come out with the kinetic energy less than h nu minus phi. Okay, we'll be going for the next question. The work function of a metal is 4 electron volt, longest wavelength of light that can cause photoelectron emission. Okay, we have given with the work function phi is equal to h nu naught, that is hc by lambda. We equate or we evaluate hc because anyhow the work function is given in electron volt. I simplify for wavelength. Longest wavelength or a maximum wavelength is nothing but hc by phi. We evaluate and we substitute the value of hc as 1240 nanometer electron volt divided by phi will be 4 electron volt. So if I solve this, 4 3s are 4 ones are 410 nanometer is the answer. 310 nanometer is the answer. So option 3 is the answer. Work function is h3 by lambda. So it's the easiest question. Okay, I think we can proceed to the next question. The work function of metals A and B are in the ratio 1:2. Okay, they have given you the ratios of a work function. If the light of frequencies mu and 2 mu are incident on a metal surfaces A and B respectively, ratio of maximum kinetic energies of photoelectrons emitted is fine. We have a maximum kinetic energy equation as h nu minus phi. Then they are told that work function is in the ratio 1:2 as well as frequencies are there in the ratio mu and 2 mu. Let me take this as phi 1 and phi 2, as this one as mu 1 and mu 2. Then I can say ratios of maximum kinetic energies of k1 by k2 can be written as h nu 1 minus phi 1 divided by h nu 2 minus phi 2, or else I can actually keep h nu minus phi itself for this one, no issues at all. So they have told that the frequency will be h nu and minus phi 1 is anyhow 1 divided by h into frequency is 2 mu minus phi 1. This is 2, okay, 2 times the phi 1. So then taking h nu minus phi or h nu minus phi, okay, I can take 2 outside, h nu minus phi, which is equal to 1:2. Basically need not to solve, we have a direct answer only, because they have told that work function is also in the ratio 1:2 as well as frequency also there in the ratio of 1:2. So for sure maximum kinetic energy must be there in the ratio 1:2. Okay, then next question. When radiation of wavelength lambda is incident on a metal surface, the stopping potential is 4.8 V. If the same surface is illuminated with radiation of double the wavelength, stopping potential becomes 1.6 V. The threshold wavelength for the surface is, okay. I want to relate the stopping potential here. So EV naught is equal to h nu minus phi. I can write hc by lambda minus phi is h nu naught, that is hc by lambda naught. So V naught can be written as h by E c by lambda and hc by E lambda naught, or else hc by E 1 by lambda minus 1 by lambda naught. This is what I have a stopping potential is. Now they have told that if we have a wavelength lambda, then the stopping potential is 4.8. If I double the wavelength, that means if I make the wavelength to be 2 lambda, then the stopping potential is 1.6. Then what about the threshold wavelength? That's what they were asking. Okay, let me take the ratios of this. Okay, let me go for a first case divided by second case, we'll try. Then what we are actually getting. In the first case, stopping potential is 4.8, which is equal to hc by E 1 by lambda. Of course, they have told for a wavelength lambda, stopping potential is 4.8. I have done a proper substitution. Minus 1 by lambda naught. Lambda naught is nothing but the threshold wavelength. That's what I have to find. then divide it by, if wavelength was doubled, then the stopping potential is 1.6. So 1.6 is equal to hc by E. They have told that wavelength was doubled, that means 2 lambda minus 1 by lambda naught. I can cancel out this, and 1.6, 4.8 by 1.6 is 3. So 3 is equal to 1 by lambda minus 1 by lambda naught divided by 1 by 2 lambda minus 1 by lambda naught. Let me cross multiply this. I have 3 into 1 by 2 lambda minus 1 by lambda naught is equal to 1 by lambda minus 1 by lambda naught. Further simplify this. 3 by 2 lambda, bring this to here, minus 1 by lambda equals to 3 by lambda naught minus 1 by lambda naught. So the calculation goes as 3 by 1 by lambda, if I take common, then I will be having 3 by 2 minus 1 equals to 1 by lambda naught. If I take it outside, then I will be having 3 minus 1. So this is 1 by 2 lambda equals to 2 by lambda naught. I want to find the lambda naught, so I can say 1 by 4 lambda equal to 1 by lambda naught. So it is so clear that lambda naught, or the threshold wavelength lambda naught, equals to 4 lambda. So option 2 is the answer. Okay, shall I proceed to the next question? The number of photons per second on an average emitted by a source of monochromatic light of wavelength 600 nanometer when it delivers the power of 3.3 milliwatt will be. Okay, number of photons per second is nothing but power by energy. So what is power? We have a value of power here, but I want, actually what I want is okay, they have given you a wavelength, right? So I want to have an energy equation in terms of wavelength. Of course I know I can write energy as hc by lambda, move this to here. So then I will be having P into lambda by h into c. Number of photoelectrons emitted is what I want. Okay, if I substitute to this, then for sure we will get an answer. We will try. Power will be 3.3 milli is 10 to the power minus 3 into wavelength of 600 nanometer divided by h is 6.6 into 10 to the power minus 34 into c is 3 into 10 to the power 8. This will be 3.3 into 6 into 10 to the power minus 1 divided by 10 to the power minus 34 plus 8 minus 26. 6.6 into 3 is 2. So 10 to the power minus 26. Okay, I have a nanometer here, so into 10 to the power minus 9, then this will be, okay, 6.6 cancels out, 10 to the power minus 10 and 10 to the power 26, so 10 to the power 16. Option 2 is the answer. Is it right? Yeah. This is 10 to the power minus 10 and 10 to the power plus 26. Yes. Next, 12th question. A monochromatic source of light operating at 200 watt emits 4 into 10 to the power 20 photons per second wavelength of the light is. Okay, number of photons emitted per second is power by energy, that is P by hc by lambda is P lambda by h into c. They have given you n, you want to find lambda, so I think I can simplify for this only. Lambda will be, I have n here, so n into h into c by power. So number of photons is 4 into 10 to the power 20 into 6.6 into 10 to the power minus 34. C is 3 into 10 to the power 8 and the power 200 watt. So this is 2 into 10 to the power 2. This can also be written as 2 into 10 to the power 2. Simplifying this, 20, 28, 4 into 6.6, okay, I cancel out 2. So 2 into 6.6 into 3, into minus 34 plus 28 minus 6 into 10 to the power minus 2. 6.6 into 6 into 10 to the power minus 8. (39.6) into 10 to the power minus 8 can also be written, because they have given you the answer in nanometer. So this is 396 nanometer. 396, actual answer is 396. I can actually choose 400 and answer which is near to that. So 400 nanometers, because we have taken 6.6, actually it is 6.625 into 10 to the power minus 34, maybe the 4, that's why we got 396 maybe. So of course we have an answer closer to that, that's 400. So the answer is option 1. Next, 13th one. The surface of a metal is illuminated with the light of 400 nanometer. The kinetic energy of ejected photoelectrons was found to be 1.68 electron volt. The work function of the metal is, okay, we have to find the work function. So maximum kinetic energy equal to hc by lambda minus phi. So if I want a phi, if I want to have phi here, so then I will be having hc by lambda minus maximum kinetic energy. Kinetic energy they have given, you want to find the energy, that is 1240, hc is 1240 nanometer electron volt divided by wavelength of 400 nanometer minus maximum kinetic energy or kinetic energy of ejected photoelectron is 1.68. Okay, I cancel out this. 62 by 20, 10 by 32 minus 1.68 is nothing but 3.2 minus 1.68 electron volts for sure. 3.2 minus 1.68. This is 2, 4, yeah, 1.42 electron volt. So option 2 is the answer. Okay, shall I proceed to the next question? The work functions of silver and sodium are 4.6 and 2.3 electron volt respectively. The ratios of the slope of the stopping potential versus frequency plot for a silver to that of a sodium. Okay, they were asking you the slope of stopping potential versus frequency. That means we have to have a plot of stopping potential versus frequency. Before that, we'll try to connect the concept first. Anyhow, I know the Einstein's photoelectric equation as K max is equal to h nu minus phi. Okay, I want to relate this. Fine. I want to relate the stopping potential, right? Okay. K max can be written as EV naught, right? So, which is h nu minus phi. Then V naught is nothing but h by E into mu minus phi. This is I can actually compare this with an equation of a straight line as y equal to mx plus c. Then what actually m is a slope. What actually m represents here? The slope m will be equals to h by E. What is h Planck's constant? What is E charge of an electron? These are the constants, right? So do you think the slope, anyhow, the plot of stopping potential versus frequency gives you the slope of h by E, which is independent of a metal, right? Because they were constants, no. So what about the ratios of the slope? Then for sure h by E is 1:1. So this is the super clarity we have is when I have a plot of stopping potential versus frequency, if I had a graph something like this, then the slope of this graph is h by E. Fine. Then the next question. The work function of a nickel is 5 electron volt. When a light of wavelength 200 nanometer falls on it, it emits a photoelectrons in the circuit. The potential difference necessary to stop the photoelectrons, as we have told, stopping potential difference necessary to stop the photoelectrons. I want to find the stopping potential. I have given with the phi work function. Work function is given, wavelength is given. I want to find the stopping potential. Okay, so EV naught is equal to, or K max is equal to hc by lambda minus phi. So E into V naught, hc is 1240 nanometer electron volt divided by lambda 200 nanometer minus work function is 5. So this cancels out. This is 10 by 62 minus 5 is 6.2 minus 5 is it right? Yeah, 2 tens and 62. 6.2 minus 5, 1.2. 1.2 electron volt is actually the answer. Okay, I can actually change this as 1.20. So 3 is the right answer. Electron volt. So E V naught, I can cancel out surely E. So for sure stopping potential is 1.2 volt. Yeah. Next one. Consider a metal exposed to light of wavelength 600 nanometer. Maximum kinetic energy of the electron doubles when light of wavelength 400 nanometer is used. Okay. Work function in electron volt is fine. They have told that maximum kinetic energy of the electrons doubles. Okay, that means if I say K2, which is 2 times the K1 according to the question. Okay, we have a maximum kinetic energy equation as hc by lambda minus phi. I want to find the work function. Okay, fine. Let me do the substitution here. Hc by lambda 2 is equal to 2 into minus 5. Hc by 2 lambda Hc by lambda, okay, they have told that lambda 1, okay, I take it as lambda 1 and lambda 2 so that we can easily solve, minus 5. Okay, so what I have is Hc by lambda 2 is 400 nanometer minus 5 equal to 2 into Hc by 600 nanometer minus 5. This is 300. Hc by 400 minus Hc by 300 will be equals to, I have minus 2 phi naught plus phi naught will be minus 5. So further simplify this, (300 minus 400 divided by 400 into 300). Into Hc. So if I cancel out this, then Hc is 1240 divided by 1200. Of course I have minus sign here also, this is minus 5. So minus sign cancels out, I will be getting phi equal to 1240 divided by 1200. I have in nanometers only here also, so only left out is electron volt. 1240 by 1200 will be, I think, 1.0, nearly 1 electron volt, right? Nearest to 1, yeah, 1.02. So that's why work function will be 1.02 electron volt. So we can actually extract the concepts from the question only. So it relates like this. Okay, we'll proceed to the next one. The work function of metals A, B and C are respectively 1.92 electron volt, 2 electron volt and 5 electron volt according to Einstein's equation. So they have given that only you have to use. Metals which will emit photoelectrons have the radiation of 6000 angstroms wavelength is. Okay, let me try to find, they have given you the work functions of A, B and C. If I had 6000 angstrom wavelength, then what may be the energy of incident photon? Let me try that. H nu will be equal to Hc by lambda, or energy of a photon is nothing but 1240 nanometer electron volt divided by wavelength of 6000, that means 600 into 10 to the power minus 9. So 6000 angstrom is nothing but 600 nanometer. So 124 is 62 by 30, 32s are 200. So 2.06 something I am getting, right? 2.06 electron volt. So we know when I can say there is a emission of photoelectrons only when h nu is greater than the work function. Let me check. 1.92 and 2 electron volts are less than this 2.06, right? So this is h nu. Since 1.92 is less than 2.06 as well as 2 electron volt is also less than 2.06, I can say there is an emission of photoelectron. Since 5 electron volt is greater than 2.06, so if wavelength of or energy of light 2.06 electron volt is incident on a metal plate, then for sure thus he will not emit an electron, right? So I can clearly choose A and B will emit photoelectrons if we have 6000 angstrom wavelength. So that's the clarity we are getting. Then proceeding to the next one. Two radiations containing photon of energy twice and 5 times the work function of the metal are incident successively on a metal surface. Ratio of maximum velocities of the emitted photoelectrons. Ratios of maximum velocities. Okay, I can relate the maximum velocity by the Einstein's equation only. According to Einstein's equation, we have k max is equal to h nu minus phi. They have told that radiations containing the photons of energy twice as well as 5 times that of work function. So I have k1 max by k2 max if I do, then what they actually mean to say is this h nu 1 or if I consider this as E1 and E2 minus phi, according to the question photons of energy twice the work function. So E1 is 2 phi minus 5 and the other one is two radiations, one with the twice of work function, the other one with the 5 times the work function, 5 phi minus phi. So will be equal to 5 by 4 phi. So I am actually getting the ratios of kinetic energy k1 by k2 will be equal to 1:4. As I know, kinetic energy is half m v square, v1 square half m v2 square, which will be equal to 1/4 for sure. v1 by v2 will be under root 1/4 is nothing but 1:2. So it's clear that the velocities are there in the ratio 1:2. Maximum velocities of emitted photoelectrons. So this is about the question number 18. Moving to the next question. When a monochromatic point source of light is at a distance of 0.2 meter from a photoelectric cell, the saturation current and the cutoff voltages are 12 milliampere and 0.5 volt. Okay, cutoff voltage or a stopping potential, that's the same thing, both are same. If the same source is placed 0.4 meter away from the photoelectric cell, then the saturation current and the stopping potential. Okay. So the only changes what we have here is initially it was there at a distance of 0.2 meter. Now what they are saying is the same source is placed at 0.4 meter away. That means you are moving the source away. In the previous question, that means while solving the first few questions, we have told that intensity is the only one which depends inversely on a square of a distance. That means intensity obeys the inverse square law, if I say. And also we have a clarity that stopping potential does not vary with the distance of the source. So I have a clarity that the only thing that may change in this is for sure this saturation current. Why? Because if intensity changes, then of course photoelectric current also changes. Why? Because intensity is directly proportional to photoelectric current. Then if I take the ratio of photoelectric current I1 by I2, or else I can take I2 by I1. What is I2 by I1? I2 by I1 can be written as R1 by R2 because it is inversely related, right, to its square. Then they have told that initially it was there at a distance of 0.2, then it was kept at a distance of 0.4. And of course, I know I2, I want to find, I know I1. How much is I1? I1 is 12 milliampere. Then this is 2. 1 by 2 whole square is 1 by 4. I2 can be written as 1 by 4 into 12 milliampere. So the answer is 3 milliampere. I2, the saturation current is 3 milliampere. And as we know, stopping potential is for sure not depends on the distance. So which will remains 0.5 only. That's why option 3 is the answer. Okay. Next. A point source causes photoelectric effect from a small metal plate. Which of the following curves may represent the saturation photocurrent as the function of distance between the source and the metal? Distance between the source and the metal. Distance between the source and the metal means I can actually relate as the source moves away, intensity R goes on increasing, because intensity depends inversely as a distance, right? So this is a graph that is photocurrent versus distance. Intensity is inversely proportional to square of a distance means I can actually relate this to the photocurrent as well, right? So even photocurrent also varies as 1 by r square. Then for sure this kind of a graph will be, this will be a hyperbola, right? So which one will be having a hyperbolic nature? So the D. That's why option D, option 4, D is the answer. Intensity is directly proportional to photocurrent. Next. The electric field associated with the monochromatic beam becomes 0 1.2 into 10 to the power 15 times per second. Okay. Electric field becomes 0 1.2 into 10 to the power 15 times per second. The kinetic energy of the photoelectrons when this light falls on the metal surface. Okay, I want to find the kinetic energy of photoelectron. Maximum kinetic energy is for sure h nu minus phi. I have given with the work function as 2 electron volt. The only thing I don't know is this h nu. Electric field with the monochromatic beam becomes 0 1.2 into 10 to the power 15 times per second. So electric field will become 0 twice in completion of one cycle. So as you know, it's a transverse. So n okay. Number of times electric field becomes 0 is 2 into 1.2 into, okay, twice it becomes 0, sorry. Electric field will become 0 twice. So 1.2 into 10 to the power 10 to the power 15. So I can say number of times, so the frequency 2 into f equal to 1.2 into 10 to the power 15. So the frequency will be 1.2 by 2 is 0.6 into 10 to the power 15. Yeah, right. Yeah, this is basically I am relating the frequency, twice the frequency. Number of times the electric field becomes 0. So we got this is EF, this is nu only. So even they have told h in electron volt. So I can do the substitution. 4.14 into 10 to the power minus 15 into 0.6 into 10 to the power 15 minus work function is 2. So this cancels out. 4.14 into 6, 4.12 into 6 into 10 to the power minus 1 minus 2. So 2.484, 24.84 into 10 to the power minus 1 minus 2 is nothing but 2.484 minus 2. 2.484 minus 2 is 0.484. So 0.484 electron volt. So this is a connected question to this electromagnetic wave. So the answer is 0.484 electron volt. Next. From the figure describing the photoelectric effect, we may infer correctly that. So okay, I have a stopping potential versus frequency graph. The two for a sodium as well as aluminium. Let me go through the options what I have. Sodium and aluminium both have same threshold frequency. For sure we don't have, because the sodium has 5 and aluminium has 10. For sure this is not the answer. Maximum kinetic energy for both the metals depends linearly on frequency. The graph itself is saying it is linearly with the frequency, right? Then stopping potentials are different for sodium and aluminium for the same change in frequency. So stopping potential is h by E into delta mu minus phi. If delta mu is same, then stopping potential is must be same ಇರಬೇಕಿತ್ತು. So ಇಲ್ಲಿ ಡಿಫರೆಂಟ್ ಹೇಳಿದ್ದಾರೆ, ಹಾಗಾಗಿ ಇದು ಆಗುತ್ತಿಲ್ಲ. Aluminium is better photosensitive than sodium. How can I say that? Why? Because look into the sodium. Sodium has lesser frequency, that means which has less threshold frequency. Less threshold frequency means it requires lesser energy, that means it is more sensitive than aluminium. So they have actually told the reverse of it. Basically sodium is more sensitive because its frequency is less, so the energy is less enough to remove the electron. Next, work function of the metal is 6.2 electron volt. The wavelength of incident radiation for which stopping potential is 5 volt lies in the region. Okay, they have given you a stopping potential. So EV naught is equal to h nu minus phi work function is 6.2 hc by lambda equal to EV naught 5E minus, so 5 plus 6.2 is 11.2 electron volt equal to hc by lambda. So wavelength lambda is equal to hc is 1240 nanometer electron volt divided by 11.2 electron volt. So 11.2 by 1240 will be 1 approximately 110 nanometer we are getting, right? So 110 nanometer. Wavelength range of 110 nanometer means which belongs to the UV region. Next. An electron is moving with an initial velocity v naught I cap along the x axis, and in a magnetic field B naught j cap, magnetic field is along the y axis, then its de Broglie wavelength, okay, an electron is moving in the presence of magnetic field, for sure will experience a magnetic force that will be q into v cross b, right, force on a charge in the presence of magnetic field. Then we basically say all these force, velocity, magnetic fields are mutually perpendicular. So F is perpendicular to V. I want to relate the de Broglie wavelength, okay, then lambda de Broglie wavelength is h by p, that is h by m into v. I want to look into the variation of velocity, because anyhow h by m is constant. Wavelength is inversely proportional to wavelength velocity. Since I can clearly say inversely proportional to velocity, how can I relate this? Since force and velocities are perpendicular, I can say work done is 0, because force and velocity perpendicular means to say force and displacement are mutually perpendicular. So work done is 0. Work energy theorem has a we have a clarity from the work energy theorem that work done equal to change in kinetic energy. So if work done is 0, then change in kinetic energy is 0, which means to say kinetic energy is constant. So half mv square is constant, means to say velocity is also constant. So if velocity is constant, then does the wavelength vary? Definitely no. So remains constant. The next, photoelectric effect, the number of electrons ejected per second. Intensity increases, number of photons increases, as number of photons increases, number of photoelectrons also increases per second. So will be proportional to intensity of incident light. Next, according to Einstein's photoelectric equation, the plot of kinetic energy of the emitted photoelectrons from a metal versus frequency, okay, maximum kinetic energy equal to h nu minus phi. Anyhow, we have already come across with this kind of explanation. There we had a stopping potential versus frequency. Now they have told you maximum kinetic energy versus frequency of incident radiation. Since if I plot maximum kinetic energy versus frequency, then for sure slope is h, which is Planck's constant. It is independent of metals, right? So it is independent, Planck's constant is independent of metal, independent of intensity of radiation. So I can say is same for all the metals and independent of intensity of radiation, because the slope what we are getting is there now h, because k max by mu is h, y equal to mx plus c. Then figure is the plot of stopping potential versus the frequency of light used in an experiment on a photoelectric effect. The work function of the metal is, okay, work function is phi naught, sorry, yeah, we have work function phi naught is equal to h nu naught, 6.6 into 10 to the power minus 34 because normally H is there in joule second into nu naught is the minimum frequency, that is 1 into 10 to the power 14, that is 6.6 into 10 to the power minus 20, minus 34 plus 14. I want to answer in electron volt, so divide it by 1.6 into 10 to the power minus 19. So this is, I have 10 to the power minus 1, 16 and 6.6, 6.6 by 1.6, around 4.1. 4.1, yeah, I have 0.414, so 4.14 into 10 to the power minus 4 is 0.414. So option 2 is answer. Next, basically I have looked into this minimum frequency from the plot. Then 28th one, a proton and a alpha particle are accelerated from rest using the same potential difference, okay, using the same potential difference. That is a idea we have. So lambda equal to de Broglie wavelength of matter wave is equal to lambda equal to h by p, can also be written as h by mv, or else I can relate it to p equal to root 2me related to energy. Energy can be written as root 2m into q into v. So these are the different formulas or different varieties of equation we have for de Broglie wavelength, and they were asking you the ratios of wavelength of proton to the alpha particle. Of course, the only that changes is they have told the potential difference is same, so h is also same, number 2 is also same while taking the ratio. So I can remove that. I can actually say wavelength is inversely proportional to square root of mass as well as charge of the given particles. I want the ratio of wavelength of proton to wavelength of alpha particle can be written as square root of inversely proportional. So mass of a alpha particle, charge of a alpha particle divided by mass of a proton and charge of a proton. So mass of a alpha particle is nothing but 2 helium 4. So charge is, mass is 4, charge is 2, and for a proton 1h1, so charge is 1 and mass is also 1, so it is root 8 is to 1. So option 1 is answer. Okay. So this is question number 28. Then the next question 29. The energy of photon is E, which is equal to kinetic energy of proton, okay. Then the ratios of de Broglie wavelength of proton to that of photon, fine. I want the ratios of wavelength of proton to the wavelength of photon, which is equal to, of course I have a relation lambda is equal to h by p. I know this is related as root 2m into E. E is a kinetic energy. Of course, the h by root 2m, they want proportionality. So I think I can just account only on the variation, how it relates to the energy. So energy of a photon is E equal to hc by lambda. This is for a photon. Energy of a proton So, from this wavelength is hc by E, energy of photon, and energy of proton is h by root E. So, I can directly say proton is related. This is for a proton I am writing. For a photon I have this. So, 1 by root E by 1 by E is nothing but proportional to E by root E. E by root E I can say, which is proportional to root E only. So, I can say ratios of de Broglie wavelength of proton to that of photon is proportional to square root of the energy. I think you get the point. So, energy of photon is hc by lambda, lambda of photon is hc by E. So, inversely proportional to E, 1 by E, and proton is inversely proportional to square root of E. And 30th one, de Broglie wavelengths of electrons accelerated to a potential difference of 100 volt is. I want to find the de Broglie wavelength. So, I had included the formulas for charged particles here, and also one more concept relating to the gas molecules. By the way, looking to this question, as we have already told, the equation can be written, wavelength of matter wave can be written as root 2 m into q into v. So, here it is electron, that is why E into v, this is not frequency, this is v. So, we are getting by equating mass of an electron 9.1 into 10 to the power minus 31, charge of an electron 1.602 into 10 to the power minus 19, and evaluating it, you are getting it as 1.227 nanometer by root v. So, I think now it is very easiest for you by substituting to this. 1.227 divided by root 100 is 10, 1.227 by 10 will be 0.1227. I think you can even note down the wavelength of proton can be calculated. If you are given with the potential difference, then you can directly use this instead of going for substituting all those things. So, this is the already calculated and given. So, looking into the units, you can substitute. So, if I want to find the wavelength of proton, then do it as 0.286 by root v, and if I want to find the wavelength of alpha particle, if the potential difference is given, then it is 0.101 by root v. So, and this is the one here, if we had given with gas molecules and temperature, in particular temperature, if they have related, then we can use this formula. So, with this we will be going for the last question. If the de Broglie wavelength associated with the proton and an alpha particle are equal, then the ratio of velocities of the proton and the alpha particle will be. Okay. De Broglie wavelengths associated with the proton and the alpha particles are equal. So, I want to relate the de Broglie wavelength, as we have already know. What is de Broglie wavelength? Wavelength of matter wave is h by p. They have told that wavelengths of proton and alpha particles are equal. So, I can equate them, right. So, wavelength of a proton equals to wavelength of alpha particle. Then wavelength is h by p equal to h by p momentum of respectively proton as well as alpha particle. So, that is h by, I want to relate the ratios of velocities. Okay. Mass of a proton into velocity of proton equals to h by mass of alpha particle and velocity of alpha particle. Then I want velocities of proton to the alpha particle. So, m alpha v alpha is equal to m p v p. Velocity of proton to the velocity of alpha particle is mass of a alpha particle by mass of a proton. Mass of a alpha particle is 4, proton is 1, because 2 helium 4 as well as 1 H1. So, 4:1, is it right? So, V alpha by Vp is mp by m alpha. So, Vp by V alpha is m alpha by mp. So, with this the basic questions of CET level was over. So, we quickly recall what and all the formulas so far we have used and what are the aspects we have discussed today. photoelectric effect, energy of photon E equal to h nu, and Einstein's photoelectric equation, maximum kinetic energy K max is equal to h nu minus phi naught. Phi naught is the work function is the minimum energy required to remove an electron from the metal surface, and we know photoelectric emission is possible only when light of energy greater than work function incident on the metal plate, then photoelectron emission takes place. Then there exists a photoelectric effect or a photoelectric current will be seen. And we have seen that how the photocurrent varies with the intensity. As you increase the intensity of radiation, photoelectric current also increases. Photoelectric current, how it increases? Why? Because the number of photon increases. Number of photon increases means more number of electrons, photoelectrons are ejected. That's why photocurrent also increases. So they linearly vary. And we related intensity. Intensity is nothing but energy per unit area per time. So per area for a point source, intensity varies inversely as square of a distance. In the same way, I have not included that. If we had a source line source, if I had, then intensity will be varies inversely as just a distance, not as r square, because 1 by 2 pi r, area is 2 pi r. So intensity is inversely proportional to r for a line source. For a point source, intensity is inversely proportional to square of a distance. Intensity is directly related to photo current. Keeping the frequency constant, I can say stopping potential will be same. That's why if we had a plot of IV, photocurrent versus anode to cathode potential, I had a nature something like this. This is anode to cathode potential and this is photocurrent. This is what the plot we had. This is I1 and I2. For a different intensities, I will be having a same stopping potential. Why? Because frequency was kept constant. This is the one. Intensities vary, so photocurrent is also varies. Stopping potential depends only on, of course, we have related maximum kinetic energy as EV naught. Maximum kinetic energy is EV naught, so stopping potential is related, or I can say stopping potential V naught depends on frequency as well as work function of the metal. This is the brief of the concepts we have used, and then by varying the frequency also we can plot the graph. If I have kept frequency constant here for this graph, if I vary the frequency, then I will be having different stopping potential. So the IV graph will have this one also. Sorry, the photocurrent will be same. Saturation current will be same, but I will be having different stopping potentials V01 and V02. So this is the aspect we have recalled, and for sure we have used de Broglie's hypothesis. From the de Broglie hypothesis, wavelength of emitted or wavelength of a matter wave is h by p, that is h by momentum is mass in product of mass into velocity, and relating momentum p square is equal to or equal to p square by 2m. So p square is 2m into e, therefore p will be equal to root 2m e. This is what we have learnt in a work energy power chapter. Relating that, I can write root 2m e also, and e is a kinetic energy here, so I can relate that to 2m into potential energy when energy of electron volt is nothing but energy of an electron accelerated by a potential difference of 1 volt. So utilizing that idea, work done will be q into v, so 2m into q into v. So these are the aspects. So far we have focused on one of the modern physics chapter known as dual nature of matter and radiation. So light behaves both as a particle as well as a wave. So light is made up of a particle called as a photon of energy h nu. Photon is nothing but a packet of energy having energy h nu, and T. Broglie told that light is a matter wave. Matter wave is nothing but wave associated with the matters. So that was actually the dual nature. So this is about the dual nature of matter and radiation. Thank you.